I've been calling this the CS3MESH4EOSC final event. CS3MESH4EOSC is a project behind the Science Mesh, but also the official title of the event is Science Mesh: Unlocking Open Science and Collaborative Research Landscape. We kind of call this the final event because the project is about to be over, but this is not the final chapter of the Science Mesh. This is just the beginning. And here we are happy to show you the work we have been developing during these years. So here our event today will be split into two parts. So in the morning we'll provide you an overview what the Science Mesh is about. We will explain how the users, software developers and also service providers can join the Science Mesh and why they should do it. We'll have generic presentations, but also share some stories from use cases from different science fields, from Earth observation, astronomy, social media analytics. So you are aware how useful these two can be within your daily life. In the afternoon, it's a more technical scope, so we'll have some demonstrations on how the Science Mesh works. We have the invitation workflows demos on about the on-cloud, the next cloud, but also since, as the name of the project says itself, the Science Mesh is also a very relevant output for the EOSC. So we have some panel discussions focused on this. We also have a presentation from our colleagues explaining how the CS3MESH4EOSC, how the Science Mesh and how EOSC can be happy together. And we also would like to thank the invitation from our colleagues from EGI for hosting our event here. We are very happy with this opportunity. And you may have noticed that there are some EGI roll-ups spread around the venue, and they have these very nice punchlines saying it's where research meets computing. And in my case, I like to think that the Science Mesh is the place where collaborative research can be done in an easy way thanks to a smooth data sharing and data synchronization. Anyway, let's kickstart with our event. So I'm Rita Menezes, Project Manager, part of Trust IT, and I would like to invite my fellow colleagues who are here to present what we have been doing. We are going to start to welcome on stage our coordinator, Jakub Mączyński, who's going to provide you an overview about the project, CS3MESH4EOSC, and also the Science Mesh itself. Welcome, Kuba. We are very happy to have you. Just a quick overview of Kuba's professional experience. He's actually from Poland, so he's speaking at home. And he's a software engineer and researcher at CERN, based in Geneva, as the majority of you know. He has a wide portfolio of activities, has been involved in projects from high energy physics, theoretical physics, medical radiation studies, and also telecommunication. Kuba, the floor is yours. Welcome.
Thanks, Rita. Actually, I would like to extend, first of all, I would like to start by extending many thanks to you and your team for organizing this event. And because it's been quite a lot of effort and dedication you've been putting to this. So thanks a lot. Okay, so do I have my slides here or? Yes, so actually it's the first time for me in Poznań because it's pretty far away from where I used to live in Poland, but I found it's a nice place, so well done, local organizers. Okay, so as Rita said, so the final countdown for the project does not mean the final countdown for the results of the project, and we'll explain you a little bit what we have done. The motivation, why we started this project, what was our approach, and also how we see the results of this project live on beyond the timeline of the project itself. So CS3MESH4EOSC, everybody agrees, is a horrible acronym. Actually, what what the project is about is building an interactive and agile / responsive mesh of storage, data, and application services for EOSC. And this is the service that we call Science Mesh. So the project is a 3 years project, which actually got extended by 6 months. So now it's a 42 months project, and it will end in 1 week's time, end of June, end of this month. And for us, it's an opportunity also to show to you what are the practical outcomes of this. So you'll see some demos, you'll see some user stories, you'll see some of the elements that are already deployed in production, and some of the elements that are still waiting to be deployed in production. The project responds to the call on the EU Horizon 2020 project for excellent science, responding to a call on prototyping new and innovative services for EOSC. We have 13 partners, and you have the project website here in this link, and this is where we document the project activities, but there's also the sciencemesh.io website, and this is where we put all the artifacts that we want to endure beyond the lifetime of the project itself. So this is the product of the project, okay? So the problem that we wanted to address starting this project was essentially several things. First is to reduce the fragmentation and data silos of the European research. So when we looked back in 2019, we realized that it was like around 500,000 users of EFSS storage services in Europe. And all of these different services actually were pretty much silos from 2 points of view. So from the point of view of being a silo, an institutional silo. So actually it was pretty difficult for these users to collaborate with users on other service nodes. And they were also kind of deployed in the pretty much in the isolation from other on-site services for research. So the goal for our project was to make it easier to collaborate on data products between researchers, scientists, and users across the existing boundaries, so be it institutional infrastructure in the country, and also to introduce more productive workflows that interconnect storage, compute, and applications. So essentially to take practical measures and steps to encourage data reuse, sharing, and applying of FAIR principles during the entire data lifecycle. Because we believe that if we bring closer certain functionalities, if we make it easier for people to reach out to functionalities that we want to encourage them to use, like for example, annotating with metadata early on, this is an opportunity for us actually to put these practices in practice. Okay? Because one thing is to discuss about concepts on what people should be doing, but typically there is quite a high bar for people to do stuff. You know, people do their research, they are very short on time, so they just take all possible shortcuts. And the last thing that they think about is preservation of data or proper metadata annotation, all of that. And this is completely understandable. This is how it works. You're just focused on what's your immediate objective and the goal. Now, what we're trying to do is have an offer which makes it easier and actual advantages for them to introduce certain concepts early on during the entire data lifecycle. And then we wanted this, so what we wanted to do is to prototype a service that could be offered as a part of the global EOSC platform. And you know, as you know very well, what the EOSC platform is actually has been evolving for many years now, so it was not very clearly defined. And it is still evolving, but the vision here is pretty clear. So we wanted to make sure that if you want to access certain functionality, you don't need to export your data sets. You can bring this functionality to where the data is, for example. And also another common theme, you know, between organizations, you don't need to resort to the, let's say, to the hyperscalers to have a common service stratum, common service. There's a risk that this laptop will fall down. You know, as a common service stratum between organizations, right? So this is this fragmentation, this silos. If we have two organizations that want to do something together, well, what's the common stratum layer? Just go to some hyperscaler and try to use that platform as a common platform, right? And that's sometimes is good, but sometimes problematic from many different points of view, costing, policy, what have you. Okay, so now how we wanted to address this? Essentially, we wanted to capture the momentum which was generated by community work on innovative services, and we focused on sync and search storage. Sync and share, essentially, it was initiated, and let's say the easiest metaphor is the Dropbox one. So we were interested in seeing how Dropbox model can function for science. What's its place? And actually, sync and share storage is interesting because the sync part makes the data available on all devices. So if you have some data in the cluster, in your HPC cluster, with this system, you can make a subset of this data available on your laptop and vice versa. Okay, so it's actually it makes for a much more complete data access continuum within your research environment. And sharing part is essentially makes the data accessible between users and user groups. So it's essentially a very easy way of making data accessible to others. The other principle is we wanted to do it, we didn't want to have just a kind of a research project in isolation. We wanted to plug it into whatever the European EFSS industry is doing. through the collaboration with a couple of these, like OnCloud and Nextcloud. And also, another important component is the community. So essentially based and on the work that is done in the community. So for the sync and share services, we have this community which is called CS3, but there's also many other things that are going around. So the way we wanted to do it is actually to innovate, do something innovative, but to reuse and leverage on existing elements as much as possible. Okay, not just a blue sky. Okay, let's start from a blank page and let's try to think of something that may or may not make sense. No, it's more like, okay, let's see what we have, what is already successfully used in different institutions, and let's see if we can propose some workflows based on these elements. And here, so we've took existing interoperability protocols, EFSS products, existing services, and we try to interconnect them in a more meaningful way for the users. And also, it's an activity beyond prototyping. Even though the call itself is prototyping new and innovative services, we really thought that, it only makes sense if you think of sustainability early on. So how do we do that in a way that when the project ends, which is in 7 days from now, these results simply do not disappear, okay? And clearly what you want to produce is more than just the reporting and deliverables, paper reports, right? You want to have something that lives on. So this is also how we approach that, including some elements in production early on. So we do have some and specifically application elements that have been developed by the project in production already. That's very important because it also allows you to contrast your ideas with the real users, okay? And of course, test driving with user communities. There are several different user communities. You will hear more about that later on. Okay, I think I'm taking way too much time for Rita's schedule.
We should wrap up now.
Yeah, so I'm wrapping it up. So we have 3 dimensions just to set the scene, okay? So there are 3 dimensions, 3 main dimensions of this project. One, we create a trust-based federation between the storage systems. So essentially this means that individuals on different systems, do I have a pointer? Okay. So these fine individuals who are on different systems, one is at CERN box at CERN and the other one is on the Surf Drive in the Netherlands, they can exchange data easily, even though they are on completely different services, different countries, different institutions. They do it through a very streamlined UI. Okay, so it's a very easy user experience, and it's enabled as a kind of a global service between the participating institutions. The next aspect is we also talk about the application platform. Essentially, we have a technology stack here that allows us to achieve interoperability between these different service nodes and also between the research services. And here we are talking about 4 different application types. Okay, data science environments incarnated by what everybody has these days, which is Jupyter notebooks. So how we interconnect meaningfully the Jupyter notebooks into this distributed workflow environment. Open data systems, so this is open science repositories. Collaborative documents, so you need to collaborate on some documentation for your project. You can do it in the same space. Sorry, it goes like this. And on-demand large data set transfers. Here, we did not want to overbuild whatever is already available as large-scale data transfer infrastructure, but for ad hoc transfers between when you want to make a replica of some data sets, that's also possible. And the third aspect is the connector of the federations. So we've collaborated with a number of entities on understanding how we can use Science Mesh and interconnect it with other infrastructures. So, for example, how to use the EGI check-in in order to access and authenticate and access Science Mesh nodes, or how to enable things like escape data lakes and data that is stored in these lakes to be visible within the Science Mesh infrastructure, so that people can easily share and access these results in both directions. So that's it. This is just big lines, and we'll see more in detail in the subsequent presentations.
In the next presentations.
Yeah.
Thank you very much, Kuba. Round of applause. I think we only have time for one question. Is there any question from the audience? Here? Any questions from the online audience? Yeah, so one very important information is that each time we have a session, we welcome your questions for those that are here, but also we have an online audience, so they are welcome to make their questions by writing on the chat they will see on the Wolva platform. And the next speaker is already here. He's eager to start his presentation.
Yeah.
He's on stage. What's your name?
Maciej Brzeźniak from PCC. I was within the project. I was responsible for the work package, working on integrating applications within the mesh. And as Kuba already explained, the mesh actually integrates systems and applications into, at least in 3 dimensions, it was said, but I will focus on the vertical integration, which means enabling to use the different kinds of applications which serve various parts of the typical research workflow. So we integrated these applications with the sync and share systems in the backend. The presentation, which will more focus on the horizontal integration, actually building the actual federation of multiple nodes distributed geographically and also organizationally. This will be presented more in detail in the afternoon session after lunch, starting at 3, where we will more focus on the mechanics and logic on the related to putting different sites together. Here, as an introduction, I wanted to bring your attention to the fact that within a Science Mesh, we already at the stage of preparing the project, we envisioned 4 main application scenarios where we wanted to provide let's say, built-in support within the federation to enable users to use their data efficiently. So it started from the observation that building a federation, the horizontal integration, which we do by nature, is one thing. And on top of this, we want users to reuse their data. For instance, we want to enable cross-site data science style of data analysis. That was actually the reason why we integrated this key 4 applications already into the concept and the proposal. More on the practical side, these areas actually include very concrete products which we integrated into the mesh. So we also tried not to reinvent the wheel and work with the components which are recognized as being the de facto standards or default tools in particular areas. Starting from data science, the Jupyter Lab is obvious choice. On the open data system side, we started from the existing, we started our work based on the existing system dealing with research data management, and we built in the feature for depositing the data from this system to popular data repositories. On the collaborative editing, documents editing side, we of course took these usual suspects, such as OnlyOffice and Collabora listed here, but we also worked on integrating tools which are more specific to code developers, to the research environments where people use not that different kinds of tools, which are not that mainstream ones, but still very popular, like for instance CodeDMG. And on the data transfer side, it was already said by Jakub, we wanted again to enable not only storing the data in sync and share systems, but also wanted to open them and make them a kind of interface towards the large data infrastructures. By providing interface, we mean the situation when a user could get to the, let's say, simplest possible data management system, such as sync and share, which doesn't constitute a steep learning curve. So he could easily start, but still have an access to large, scientifically interesting data sets through the built-in integration, and that was actually the assumption. So, oh, yeah, PowerPoint has some issue, so let's wait. Okay, so actually, I think I could actually stop here. These 4 areas are covered. Were covered through 3 years of the project work. In every single area, we prepared proof of concept, but we also have production-ready existing installation at the partner sites. And what is important is that we also, by offering the applications which actually address the practical scientific workflows, we also kind of open the doors to the users so that they can immediately see the benefits of this integrated approach. And we managed to onboard several new institutions which are not initially included in the partner list. And the presentations which follow after my introduction actually show these cases where the adoption actually happened and it resulted in production-ready solutions. Okay, so thank you very much.
You're welcome. Round of applause. Are there any questions for Maciej before we go to the next presentation in the room? Okay, give me a second. Would you mind to say your name before posing the question?
Sure. Thank you so much for the presentation. I'm Sagar from SURF. My question is more on the on-demand data transfer side. How easy it is to instantiate this on-demand data transfer for a normal researcher? I'm not talking about a researcher from the big science collaboration community.
Okay, so let's maybe I will start the answer, and maybe this will be extended by Ron, who was actually coordinating this task. But starting from the easy answer, we wanted this automated, let's say, managed data transfer feature to be as easily available as all the other features in the sync and share system. So normally, if you have some experience with using sync and share systems, you know that your data are organized in your folders, your data, shared folders, group shares, and so on. And we wanted this transfer mechanics to be as easy presented, so that you in fact have some kind of your view on the data which are transferred is in the ideal world similar to is actually some special case of the shared data. You just see them like they would be local. You can access them on demand. That's actually this on-demand aspect. So for the end users, beside the higher latency while accessing this data which were stored remote, the idea is that in terms of his workflow, his interaction with the sync and share, nothing changes. He could, of course, nothing is perhaps an exaggeration, but that's the approach we wanted to offer.
And how does it work in terms of geographical context?
And this is maybe the more difficult part of the answer. I mean, we, of course, to deal with geographical distribution, you have to implement and integrate mechanics which actually deal well with latency. That's why we use these tools which are listed here, like starting from Arclon, which already can use multi-threaded transfer to just overcome the latency problem, but also these solutions which are well established in applications such as high energy physics, where you deal with really distributed infrastructure and large sets of data in terms of many terabytes. These all tools support multi-threaded transfer and so on, some kind of state control of the transfer itself, automated restarts of the transfer and so on. So we kind of reuse the mechanics which were developed for years for dealing with large research data, and we interface to these mechanics. We're not like replacing them. We wanted to provide an interface, transparent interface to these.
Thanks.
Thank you very much. Any further questions here? Do we have online questions from the audience? Not online questions. Okay, thank you very much, Marcia. A round of applause.
Thank you.
Thank you very much.
Something happened to my power.
Okay, we are getting ready for our next session, which will have the presentation of the use cases we had in this project. So I would be happy to call on stage my colleague Marcin from Software Mind, also my colleague Ron Trompert from SURF, and we also have two panelists, two other panelists, one from remote, which is Henrique Tejedor Saavedra, and we also have a fourth panelist, which is Leonard Hofditz. Unfortunately, he cannot join us in the last minute, either here in Poznan or online, but he prepared a recording of his presentation. And if you have questions regarding Leonard's presentation, we have colleagues here, namely Holger from University of Munster, who will be happy to help you and reply the question regarding to his presentation. So, maybe a first overview of our dear speakers. Let's start with Marcin. Marcin, he's a experienced system architect and research and development project manager with more than 20 years of enterprise software design and also development. He is also the founder and the leader of Big Data Lab. Regarding Henrique, who is joining us online, he conducted his PhD research as a member of the Grid Computing and Clusters Group of the Barcelona Supercomputing Center. Since 2015, he is part of CERN, and he leads the operations in the SWA. Regarding Leonard, the speaker who provided the recording, he is a member of the Business Information Systems and Digital Transformation Research Group at the University of Potsdam. Last but not least, we have Ron Trompert. He is the group leader of the Online Data Services Group at SURF. He is also responsible for the SURF Object Storage Service, which is known as SURF Drive, and he has been involved in the LOFAR long-term archive. So, thank you very much for being here with us, also our online speaker, and I would like to pass the floor to Marcin, who will start the session with his presentation and demonstrator. Welcome.
Okay.
Hello, my name is Marcin Sieprawski. I lead Big Data Lab in SoftwareMind. I'll present how Voila and Voila dashboards can be used to create powerful interactive dashboards based on Jupyter notebooks for Earth observation data science projects. Let me start with a very brief introduction to data science environments of Science Mesh. As a core component, we created a Jupyter Lab extension integrating with Science Mesh, which allows us to provide additional sharing and collaboration features in Jupyter Lab. The share functionalities are available directly in Jupyter Lab file browser, the sharing buttons, entries in the menus. The share window presents the status of the share, the list of grantees, and it allows searching across the connected federated sites of Science Mesh for users by name, surname, full name, username, or email to create new shares or manage shares, like changing the role from viewer to editor. The shares tab that we added allows me to see the file shared by me and also the files shared with me. Collaborative workflows allow a group of users to work on the same notebook and are powered with Science Mesh locking mechanism for override protection. The file locked pop-up allows to open the locked notebook in read-only or create a copy. The collaboration workflows will be demonstrated in a moment in high-energy physics talk. I'll focus on the interactive dashboards. So we can share the notebook as read-only for the viewer role, and then the users, the grantees, cannot change the notebook, cannot change the code. But the code cells are still visible. Voila allows to create automatically standalone applications or dashboards from Jupyter notebooks in a way that only the interactive outputs of the notebooks are visible and the code cells are hidden. And Voila simplification library developed by JRC, this is dangerous. JRC, the Joint Research Center of European Commission, the Earth observation use case of Science Mesh. The library helps in easier creation of complex combined Voila dashboards from the notebooks, and the library is now ready to be published and as open source. Voice library facilitates using advanced sets of widgets and combining the widgets in a consistent way with less code. So those are the actual elements that allow users to interact with the notebook's outputs. Voice library also helps integrating interactive maps, CSS3 tricks for supporting full screen and responsive dashboards for various screen resolutions, plots or custom charts based on vector graphics and supporting the events in JavaScript. As you can expect in this talk, the library also has a big set of features supporting creating powerful interactive visualizations of geospatial data. Here, you can see the dashboard that allows interactive creation or definition of such a visualization based on a couple of sets, and the user can define the visualization following self-service BI trend. And probably this is too much for this laptop. Okay. Okay, so this is last slide. So finally, this is the summary of Science Mesh Earth observation use case. The Joint Research Center of European Commission created JRC Big Data Analytics platform with multi-petabyte infrastructure, and one of the service layers of this platform is based on Jupyter Notebooks, allowing interactive analysis and exploratory visualizations based on geospatial and non-geospatial data. And Voice Library is used inside European Commission Big Data Analytics platform to communicate research results to a wider community. So this is enough for talking about visualizations. So we can see multi-page dashboards, geographical visualization, interactive maps connected with various widgets. The changes or interaction with the widgets change the data that are displayed, and also data in other widgets. Yeah, the map is interactive. The interactive maps combine the tiles of the map with the augmented layers of data. Also allow additional layers for other components, the charts. We can connect with various data sets. So this is important that this supports very large raster data that can be visualized quickly. Again, we can see multi-page dashboard. You can drill down to detailed data. You can use the data catalog. Thank you. Hope you liked the music. So basically, what is if somebody is up to date with current business intelligence and various big data tools, this is nothing unexpected. But so there's a lot of solutions like that. But usually they use very, very expensive tools. So we do that in many projects, but usually it's backed by some very expensive platforms, and this is all created with open source software and can be created quite easily. So yeah, once this library, the voice library is open source, be invited to use it, and also check our Jupyter Lab plugin for Science Mesh data science environment. Thank you.
Thank you, Marcin. So this was our Earth observation use case. For questions, if I may, for the benefit of time, if you have any, please save them till the end of the session. So we will follow, we'll see the presentation of the 4 use case, and then at the end, we'll respond to some questions. Thank you, Marcin. And in the meantime, it's time to hear to our online speaker, Henrique Tejador, who will talk about the high energy physics use case.
So yeah, thanks again for the invitation. I'm Henrique Tejador from CERN, and I'm the service manager of SWAN. SWAN is the service that we provide at CERN, which covers several use cases in the field of data analysis for high energy physics. And in my presentation today, I'm going to describe a little bit what those cases are. So SWAN is a service that allows you to do interactive analysis with a web browser. This means that you connect to this online service. You don't need to install anything locally. You connect with your browser, and you get the Jupyter Notebook interface where you can do your analysis. So basically, all your calculations, the code that you run, the input data that you need, everything is on the cloud side, on the server side, right? And then this kind of service enables for easy sharing of scientific results. You can, through SWAN, you can choose to share your work, your analysis with other scientists, your plots, your data, your code. I'm going to give more details about that later. And it's, in general, it's a service that is good for data analysis and exploration, but also for teaching, as I will also mention a bit later. So the interface is Jupyter Notebooks, but what really makes it useful in the context of CERN, because in the end, there are tons of Jupyter deployments everywhere. What makes one useful at CERN is that it integrates with CERN resources, and in particular for software with CBMFS, for storage with EOS and CERNbox, and also for computing. It bridges you to be able to use computing resources, for example, Spark clusters, or HD Condor pools at CERN, or more recently, we have added the capability for the service to provide interactive access to GPUs, which is something that is in growing demand from our users. So these are all the building blocks of the service. I already mentioned software, storage, computing resources, the interface. I will just mention here the analysis frameworks. For this service to be useful, it has to provide all the analysis frameworks that scientists at CERN they use. Mostly, when people use Swan, they prefer the data science ecosystem provided by Python libraries. So Python is the most used language in Swan, but there are also people that are doing things in C++ with other analysis frameworks. And even more recently, we added Julia because it seems that it has also a growing interest in our community. But what is important here is not to tie yourself to any particular framework, but to provide as many as you can and cover more use cases. About software, I mentioned we use CVMFS. CVMFS is a distributed file system that has been deployed at CERN, that has been developed at CERN as well. And in that distributed file system, there is a team of librarians at CERN that maintain software packages, software stacks. So basically what they do is they gather all the requirements from all the experiments at CERN, and they construct these software stacks that have hundreds of packages. And then in Swan, we rely on that, and we make those software stacks available. So when you log into Swan, you don't have to worry about installing stuff most of the time because you already have a lot of packages available there to do your analysis. So this is what is called here the LCG releases, these hundreds of packages bundled together and offered to the users. So you don't, as a user, you don't need to provide any Docker image with the software or anything. You don't need to worry about that. What you can do, you have the possibility to do it, is you can add more packages than those provided by CVMFS by installing them on your EOS space. Because in Swan, we also make EOS available. So EOS is the mass storage system for CERN. It's where all the experiment data is. And when you start a session in Swan, your home directory is actually your EOS user directory. So it contains your personal data. And in that directory, you can create your projects. You can create your notebooks, input data, output data that you generate. And then you can leave Swan and come back the next day, and everything will be there for you to resume your work. You can also access other repositories on EOS that belong to the experiments, so that if you are collaborating with an experiment and you need some data that is there, you can use it as well, and that's available in Swan. And then another integration we provide is with CERNbox, with this layer on top of EOS for sync and share, so that you also have the option as a scientist to say, okay, now I have this analysis that I produced on this data, and now I want to share it with my colleagues. I can do that through Swan. And in particular, how this is done now, this sharing part with CERNbox, is by means of cloning. This means that I can be a scientist working on some analysis, and then when I'm done and I want to share it, I can share it with one or more other scientists via Swan. And then the scientists, they can see what I did. They can inspect the contents of that folder that I shared with my notebooks and so on. But in the moment that they want to write, that they want to edit those notebooks, they want to produce maybe another version of that analysis, they need to clone. So they copy that project into their own space, and then they continue working with their own copy, and they might modify their own copy. So of course, this is not ideal. Why? Because, well, once I made a copy and I generate a new version, and maybe I need to share again with my colleague, that colleague will need to create again another clone, right? So you create this proliferation of clones, which is not ideal. It was done like that because when we implemented this, the collaborative sharing or collaborative editing of a notebook was not really supported, in the sense that if you wrote at the same time, two scientists writing the same notebook, they stepped on each other, they basically overwrote their work, and this was a safe way to prevent that. But maybe we could go now towards a better model, which is actually something that is proposed inside CS3MESH, which is this parallel editing. And here, parallel editing means that I can create my analysis and I share it with someone else. And that someone else actually is going to work on the same copy, on the same original analysis that I did. And when that scientist opens the notebook that I produce, it will she or he will acquire a log on that notebook, and this way we cannot really bother each other. Right? So the user will work with a notebook, maybe produce another version that then maybe when they are done with the notebook, I can go and I can inspect the notebook and maybe continue modifying it afterwards. Right? So. And then I don't have this back and forth of the clones, which poses a little bit of a problem. It is true that still this model is not fully concurrent editing, because it's not two scientists editing the same notebook, different cells at the same time. It's not that. But to be honest, at least the experience that we have from our users, no one has really told us that they need concurrent editing of the same notebook at the same time for their work. So I would say that most of the use cases would be covered by just parallel editing, and it would improve already on what we have. Then going a bit on the use cases that we have at SWAN. So what do people use SWAN for? The biggest use case is using SWAN for physics analysis. These in the context of CERN or in high energy physics in general. This means analyzing data that comes out from the LHC, from the collider. So these are collisions. These are data events about collisions that are stored. They are collected and stored, and then they are analyzed by physicists. When they analyze this data in SWAN, this data, they look like basically columnar data, where the columns are just numeric types or arrays of numeric types. And with this, the scientists, they just produce their plots in SWAN for their final analysis. And another thing we've seen more and more is that people for analysis in the context of high energy physics, they are using machine learning. And this links with the provision of GPUs that I was mentioning earlier. This is becoming more and more important because they incorporate machine learning in their analysis, and they need GPUs to speed that up. So it's important to provide them with interactive access and also batch access, but this is the goal of other services at CERN. But in our case, interactive access to GPUs and to software that can run on those GPUs, right? So this is very useful for them and has a growing demand. Then another use case we have at CERN is non-physics analysis. So this means that not all people are going to analyze data that comes from the collider, physics data. Some of them, they analyze other kinds of data. They are not physicists, they still are scientists or engineers, but mostly what they do is they analyze data that comes from the monitoring of the machine itself. So they collect all these logs, all these measurements from several devices that are connected to this big machine that is the LHC. And they want to know how the machine is doing, how is everything going, if the operation is normal, and so on. So they query that data from SWAN, and they produce plots to analyze what's going on also from SWAN. And that's also quite a big use case, I would say. Then education, I mentioned earlier, we have many requests from schools, workshops that want to do trainings, and they want to use SWAN. So they create exercises in the form of notebooks, and they want to use SWAN for giving those exercises. And more here as well, we are getting requests for machine learning tutorials that need GPUs. So GPUs are also in demand here. And then finally, outreach. SWAN can also be used to do analysis of open data in high energy physics. And this actually links with my last slide, where I talk about open science. So at CERN, we have this initiative, CERN Open Science, which wants to make available the research of CERN to other researchers around the world and in general to society. And this means not only publications, but also software and data as well. So CERN and the experiments at CERN, like CMS, Atlas, and so on, they have opened their data. So this means the data that is collected from or extracted from the collider, right? Collision events. From a few years ago, they have released them, they have published them, and then people can go and see them. And this is useful, for example, for training of future scientists. or in general for outreach and dissemination of the kind of research that is done at CERN. And maybe related to the previous presentation by Marcin, actually Voila could here be a good tool for showcasing this research, because one can think that we can have also physics analysis in the form of a notebook, and then we generate a Voila dashboard out of it, which is actually what I did here in Swan. So you have Voila in Swan as well. And what you see here is just the last part of an actual analysis, physics analysis that uses the open data of an experiment at CERN that is called CMS. And this Voila dashboard, it doesn't have these Jupyter widgets that were presented before, but it has this interactive display. So this plot is actually interactive, and people that are using this, they could just go and play a little bit with this display. So this could actually help also in these dissemination activities at CERN. And with this is the end of my presentation. Thanks for your attention.
Thank you very much. Let's leave the questions till the end. And now let's go with Leonard, our speaker, who unfortunately could not join us, but kindly prepared a recording of his presentation.
Welcome to this presentation on how Skibo RDS benefits RISE SMA. My name is Leonard Hofedetz. I'm Research Associate at the Research Group of Business Information Systems and Digital Transformation at the University of Potsdam, at the chair of Professor Stefan Stieglitz. Our research group is part of the RISE Social Media Analytics project. This project is an EU-funded project, part of the Horizon 2020 funding scheme, and considers social media impacting, on the one hand, society, and on the other hand, crisis communication. We consider information extraction and also do research on information dissemination, and consider topics and different dynamics and also actors and roles from crisis communication, different organizations, for example. When I mean we are a group of universities from different countries and also practitioners from different countries. So our research group used to be part of the University of Duisburg-Essen, now moved to the University of Potsdam in Germany, and also part is the University of Leiden from the Netherlands, University of Agder from Norway, the Kristiansand Kommune, which is a city government in Norway, Virtimo, a developer of Berlin, Unisinos, university from Brazil. Then we have the University of Indonesia as well, and then two universities from Australia. So the Queensland University of Technology and the University of Sydney. And all these actors have different expertise. So researchers from business information systems, computer science, mathematics, and communication science. And together we conduct research on these two topics: societal impact of social media and crisis communication, and how social media impacts crisis communication. So let me give you one example of a project, sub-project we are conducting in this project, this main project. So one research project I was involved in considered conversational agents in crisis communication. Together with colleagues from my university, from University of Sydney and University of Edinburgh, we considered how we could derive design principles for conversational agents to support emergency management agencies. We published this article already in 2021, and I want to give you this article as an example of how we conducted this research. So we had two different data sources. On the one hand, expert interviews with representatives of emergency organizations in Germany, especially from the lands of North Rhine-Westphalia and Hessen. So these were 6 interviews with practitioners, experts from organizations like the Johanniter, for example, and experts from state institutions as well. And on the other hand, we had data from Australia after we interviewed experts with representatives of emergency organizations from different states there. So this are 13 interviews, so from different states and different organizations. And in the middle, you can see a few keywords. We also tracked social media data to get an understanding of their problems. So for example, in Australia, one of the biggest problems is bushfires, also floods, which they have in common with Germany. Also, more and more has a problem with flooding. Yeah, and considered these 2 cases. So when we did this, we used Skibo, which is based, so it's a sync and share service based on OwnCloud. And we used it to store our data, to work collaboratively. So creating folders, working in shared documents, so like Word documents and Excel files, for example, Excel sheets and so on. Yeah, and used it. And one problem was that it was very difficult to give everyone involved in the project access to the folders. However, we could solve this problem by using Skibo RDS. So just to give you a few screenshots, this is a screenshot of how we worked collaboratively. So I, for example, created a guest account for one of the authors from Australia. And when we worked on the documents or the article, the research article, yeah, we used the commenting and editing functions here of OnlyOffice, which is included in Skibo. So Skibo is limited to North Rhine-Westphalian universities in Germany. So if you are not part of one of these universities, one who is part of the universities has to create a guest account for you. So, but this is not longer necessary. So if you, for example, want to share data sets, you can do this by Skibo RDS, which really helps us. And which is also very helpful is that, for example, another partner, University of Leiden, they have their own cloud service, their Surf cloud, and so also the sync and share service, and they can use the service and provide us access to their cloud, and we can provide access to them from Skibo. So this is one improvement which we really like, and another improvement is the Skibo RDS, which I will explain in a second. So when we published the article, there we considered the publication steps of the journal we wanted to publish in. And they said on their website, if you want to publish, then it's important to consider the research data. And the journal encourages and enables you to share data sets to repositories. And it's possible to link the published articles and the data sets, which benefits you with, for example, more citations and more visibility and also reputation. So that's why we considered to publish our data. And this was difficult For example, if you do it via the Open Science Framework or Zenodo, because you create an account, download everything from our Skibo cloud where we have the data and then uploaded it again on the data repository. However, with Skibo RDS, it's much easier. So this is one suitable data repository we considered, the Open Science Framework. And you can see some of my projects I already created manually. And this is not longer necessary because we ask ourselves, how can I apply this uploading process as a researcher with as little effort as possible? And Skibo RDS helps us with this. This is a screenshot from Skibo RDS, how it looks like at the moment. On the left side, you can see that there are two repositories selected, the Open Science Framework and Zenodo. And we aim to publish a dataset at the EOSF. So this is why I want to show you in a short demo how we did it and can do it in the future. As you can see here, we also used the OnlyOffice option in Skibo for this presentation. We can go now to the folder here. We have here our data. Go here to the RDS app. And can see now, okay, there are different repositories. So the OSF, we want to connect the OSF to our account, approve this. And now the OSF is connected. And we can create a project here by picking the right folder, which is here. Select only the data folder. We want to have both codings and transcripts. Select it, give it a name, so just an exemplary name. Skibo RDS RISE SMA, and can now select the OSF here. Press continue. Now we have the option to select some metadata. So a title, which is called conversational agents in crisis communication. We can select a category for the OSF. It is data what we have. Add a description. Project. Part of the RISE SMA. And now, by pressing continue, we can see, okay, we have data, which is in OwnCloud. So as I said, Skibo is based on the OwnCloud, so you can share service, and we can publish it to the OSF. I'm not going to press the publish button because it's already live. And I just wanted to demonstrate how we can benefit from Skibo RDS when publishing data sets and when working collaboratively when we use Skibo and the OnlyOffice collaborative working. So this is a short demonstration from the RISE SMA project. Thank you for your attention. And if you have any questions, I can't be here today at the conference, but feel free to email me and ask whatever you like. Thank you.
We thank you, Leonard, to provide this. As Leonard said, if you want to reach him directly, you can come to me and we'll provide you his email address. Well, moving swiftly on for our next speaker, Ron, who is going to present the use case related to astronomy. Welcome, Ron. Let's hope the PowerPoint works smoothly this time. And this is it. Yes, okay. Go ahead.
Okay, good. Still morning, right? Good morning, everyone. Well, it's funny that my colleague Sagar from SURF is also in the audience. So now, finally, after traveling all the way to Poznan, I get to tell my colleagues at SURF what my group is doing. Any case, on-demand data transfers. That's it. What I'm going to discuss with you now is just, let's say, the work that we did within the course of the CS3MESH4EOSC project on data transfers, and more in particular also about the demo that we're going to show a little bit later on. About the demo, there has been the ESCAPE project that ran a few years, and it ended in January last year. We're also in the company of Xavi, the work package leader of WP2 of ESCAPE, so all the questions about ESCAPE, they're Xavi. Yes. Okay. This project was about addressing the common needs of several SRIs, more in particular also astronomy, high energy physics and others. And yeah, the work has been done within this project on a number of components that those SRIs have in common, and those are listed here. Due to time, I'm not going to discuss too much detail here. But about the work that we've done on data transfers, basically we have addressed two types of data transfers. First one is more just the ad hoc data transfers, typically from one user to another user at another single share service, or one research group to another research group. Not really organized scientific communities, but just individual research groups. And we've developed something that is based on rclone, which is a well-known tool to, let's say, address storage spaces at something like 40 plus different cloud storages. The other one, that is the managed data transfers. That is about, let's say, the organized scientific communities that have petabytes or even exabytes of data that they share together. Communities that have evolved around them, they use typically tools like the file transfer service developed at CERN to copy files from one place to another, and also this involves a federated AI system, which can also be connected to the Science Mesh, by the way. Okay, well, this is the ad hoc data transfers. I'm not going to say too much about it because this, yeah, it's a little bit of a complicated picture, but basically you, what you do is one person invites, let's say, another user to have, let's say, a transfer type sharing request. The end user accepts that, and then at the sync a share service, let's say an rclone daemon is fired up that collects the file from the originating site. Well, this is a typical example, of course, of managed data transfers. This is the stuff that WLCG is doing to copy the LHC data all over the planet. So, okay, about the demo, it's really about, let's say, getting the data from the telescope, so astronomy use case, getting data from a telescope, put it in a data lake, and from there to get it into the Science Mesh and to distribute this data to other users not directly connected to that data lake. So in fact, what we're trying to do here is to, let's say, connect. Kuba was already mentioning it this morning, that to let's say connect one infrastructure together with another. And here we have three actors. We have Stella, that she manages the data coming from the telescope. And she has access to storage infrastructures belonging to the escape data lake. And there we have Jan, our primary investigator, that has access to a sync and share service at SURF. And that sync and share service also happens to be part of the escape data lake and is also a part of the Science Mesh. And at Chestnut in Prague, we have Mirek, and Mirek has access to his own sync and share service. And what happens next is that Stella says, okay, replicate data from LAPP to SURF. And what the FTS does is make sure that, let's say, the storage element at SURF will to pick up the file. And if that happens, the file is copied to SURF. And then what she does, using federated AI, logs into the SURF sync and share service and shares that data set with Jan. Okay, Jan sees that, accepts the share, sees the file, and then he will just share it with Mirek, and Mirek accepts the share, logs into his own sync and share system, and sees the federated share from Jan. So, and now I can show the video. I'm not touching anything because I will break things.
Be blind.
Okay. I feel discriminated. There's no fancy music underneath. Okay, well, here's the FTS. Sorry, this is the only command line stuff that you're going to see, but apologize for that. Here's the FTS that copies the file from LAPP to SURF. Then you look at the status of the transfer. Transfer got stuck. Yeah, and lo and behold, it's finished and successfully finished. So from LSWG, the file has been copied to SURF. So now we're going to see GUIs. Stella logs into the SURF sync and share service. And this is our favorite customer, Miskatonic University. So, and there it is. The file that she copied to SURF. Now it's going to share it with Jan. And now Jan is going to log into the SURF sync and share service and accept the share from Stella. And there we have the file again. So, and now Jan is going to share the data with Mirek, and of course Jan needs to find out the sync and share servers Mirek has access to, and also Mirek's ID. And for that we have an invitation workflow. I'm not going to show it here because of time, but there is an invitation workflow put in place where we can find, let's say, the user ID and also the remote EFSS from the user that you want to share with over the Science Mesh. But here we have done this invitation workflow, and here we see Mirek, and we can now share data with Mirek. So now Mirek is going to log in into a sync and share service and accepts the share and then has access to the file. And that's it. And that's all for me. Thank you.
Thank you, Ron. Okay, I believe we are quite late, so there is time for only one question. If there is any question from the audience here in the room for any of our speakers. Okay, any questions from the online audience? Letizia? Nothing? Okay. Marcin, Ron, Enrique, and also Leonard, thank you very much for being with us.
Thank you.
Now, let's move swiftly on for the next session, the last one before lunch. So it's our first panel discussion for the day. I would like to invite to the stage Pedro Ferreira, who is the CS3MESH4EOSC technical coordinator from CERN, and also like to invite Xavier Spinal, also from CERN, in representing the ESCAPE Former project, Andreas Klotz from HIFIS, and here in Poznan, Joszek, I hope I spelled properly your name, from the PSNC, and also we have one remote panelist. His name is Robert Scheidt from University of Paderborn and a member of the High Performance Computing RHW project. So thank you very much for joining us. And I'll pass the floor to my dear colleague Pedro, who will manage the session, and I'll introduce the panelists.
Thank you. Is this on? Yeah, I think it's on. So yeah, thank you very much for this introduction, Rita. So the title of this panel is Trends and Priorities for Cross-Border Multidisciplinary Science Collaboration and Innovative Technical Partnerships. It's quite a long one. But to put it short, so I think everyone in this room agrees that has been a lot of progress in the last decade or so in providing tools to researchers, and there's a wealth of options and tools and workflows available. Of course, the question is, will we somehow converge it at some point into some sort of solution, or at least a set of solutions which researchers can use at a European and even, who knows, at a worldwide level? And how do we democratize access to these tools? So if you want, we will be going a little bit bottom up, looking at the use cases that we have at our various institutions, at our various federations, and working up from there and trying to make sense of the current panorama and what can be some of the aggregating efforts that we can go for. So I would suggest that we start by introducing our speakers. So I would ask, perhaps we could start with Robert, who's on Zoom. So Robert, if you can give us just a very quick introduction about yourself.
I'm happy to, and it's a pleasure to be here. My name is Robert Schade. I'm technically a scientific advisor for solid-state physics and quantum chemistry at Paderborn Center for Parallel Computing. That's a NHR, so National High Performance Compute Center in Germany. So my job is basically to support users in their day-to-day life and workflows and everything in the context of physics and chemistry. On the other side, as was already mentioned in the beginning, I'm a coordinator in the competence network HPC NRW, so the competence network for high-performance computing in North Rhine-Westphalia in Germany, where also Skibo is located. And there we deal with all the problems and challenges that we have in high-performance computing, from compute time proposals to data management and everything.
Thank you very much, Robert. So maybe Andreas, you can go next.
Thank you. Yeah, I'm Andreas Klotz. I work at Helmholtz Center Berlin, where I manage the local HIFIS cluster. HIFIS is Helmholtz Federated IT, and I'm basically the architect of the Helmholtz cloud.
Morning, everyone, or afternoon. I'm Xavier Spinal. I'm leading the engagement at CERN for the research and computing sector, and also member of ESCAPE.
Hi, I'm Wojciech Stefaniak, machine learning and robotics engineer at PSNC, and also an educator for high school students. I educate about data science and machine learning, and probably that's why I'm here to talk about our use case of Jupyter notebook platform.
Okay, so just one round of applause for our speakers, please. I would suggest that we start from some general questions, very open questions, and then maybe start getting into the details. Towards the end of the session, then maybe we can open also the discussion to the floor if someone has some questions for our speakers, or if they want maybe to provoke them in some way. So I would start with a very specific question, which is, so let's start from your local environments, and maybe we can start with you, Andreas. Starting from your local environment, from your perspective, in this case of HIFIS, of your federation, what do you say are the main pain points that the researchers face in the handling of data, and how can the Science Mesh help them?
Yeah, the Science Mesh is especially for us in Germany, it's extremely relevant. We have this weird limbo situation where we want to have even more and more data sovereignty, have data on-premise instead of in the cloud, not have scientists use Google and such. And so we all have these enterprise file sync and share systems, but we still need to collaborate somehow. And up until you from Science Mesh came along, federation of EFSS meant that you exchange the whole user database, and you might imagine how German data protection officers might like that. So now we have the option of a more data GDPR compliant way of sharing data and collaborating across institutions and across research fields. So thank you very much for that.
Thank you very much, Andreas. A very good point. The data protection, GDPR, of course, is something which these days is extremely relevant. So I would move on then to Xavi. Would you like to make the same exercise from your point of view as someone working in high energy physics, doing engagement with high energy physics at CERN, and also from your work with ESCAPE, which Ron has already mentioned? What would you say are the main challenges that our researchers face today, trying to collaborate in a pan-European environment? You have the microphone.
Okay, good. Yeah, so I think one of the important aspects is that the way the users do analysis is evolving. I mean, when I was doing my PhD, we were practically working on terminals and then doing basically pre-staging the data and waiting for some days. So right now, the way of working changed. All the panorama of notebooks, web interfaces, the availability of data is changing the paradigm. So the fact that the Science Mesh, CS3MESH project is kicking in and is interesting to narrow the gap between what is the experiments big data, these data lakes, or basically the catalog of the experiments, and to put this data really at the level of the users. Now, the users are I would say two types. One are the hardcore people doing PhDs and a large-scale analysis where they should run probably thousands of jobs. But there is also another aspect, which is the one when the analysis is much more advanced and you have a few data, which is the one that you really want to analyze, and then you start writing the paper and you need to share it with your collaborators. So these are two aspects that are different. And the later one I mentioned is the one probably addressing better now in Science Mesh. But there is the possibility to bridge what I have seen today, this voila inside the notebooks, that you can have kind of interactive way of moving the code and then plotting the data. This is really a point where I think we should put the focus on the next years. The fact that the gap between large-scale analysis and very focused analysis is large. It's because that probably this large scale needs thousands of jobs, hundreds of terabytes. What we really need, I think, our users is to be able to play with a subset of data, and then from there, from this notebook, from this mesh, be able to fix and to tune the analysis and then scale out on local resources. We have seen from Enrique this interaction with local clusters, with GPUs, and eventually with HPCs and cloud. So this is probably one of the things that I think we are moving towards, a kind of a holistic approach on the analysis.
Thank you very much. And you've mentioned notebooks and visualization tools, and I think this is a really great segue for Wojciech. So would you like then to present your perspective on this?
Yeah, when we talk about science, we usually focus on scientists who do it as their jobs. But we in Poznań deal mostly with students which are setting their first steps in this field. They are just getting to know data science and machine learning. And to be honest, while I was studying, it was very hard to go through all those steps of getting to know the system of Linux or macOS and the terminal. And then you have to put your data somewhere, then make a virtual environment. And now all of those problems are fixed with the frameworks, the solutions that are made here in the Science Mesh. So yeah, that's great for sure. It enables youth to just it brings down it all to the simple user interface, and they can just play with the data, play with the notebooks.
Thank you very much. And you, Robert, I expect that in your case the level of complexity and user-friendliness will be completely different. Would you like to present then your perspective on these? What are the main problems that HPC researchers dealing with HPC face in this moment?
Yeah, I'd be happy to. So we have basically two aspects. So on the one side, the already mentioned like large projects that have their own data management section and so on. They work usually flawlessly, but we also have a really big crowd of, let's call them the normal HPC users. They come from smaller systems, then go to higher tiers in the HPC pyramid to larger centers, have to transfer the data between centers, between their home workstation and the HPC centers, and then suddenly this one HPC center is too small, then they go to the next level and to the next level, then maybe even to the Praise level or to the GCS level and so on. And this data migration is a huge pain point for us in HPC, because you might remember in 2020, 2021, we had these security incidents in HPC where attackers got root privileges on one HPC system and then hopped from one system to the other and infected a chain of HPC system. As a consequence, most HPC operators nearly completely locked down their systems to prevent that in the future. But that also prevents data transfer, obviously. And that's one of the biggest pain points that we're having today, and that where, for example, Skibo, that we're actively collaborating with, and Science Mesh can hopefully help us to connect all the levels of the HPC pyramid, all the different sizes of HPC clusters, and together, not just the large ones, but also especially the small ones that don't have a lot of personnel to actually maintain their own Science Mesh node or something like that.
I'm curious to know, Andreas, do you share these this view with regards to the mesh? Because I see that one of the roles that the Science Mesh could play in HiFIS, for instance, could be enabling connection between people who are currently part of the HiFIS ecosystem and other ecosystems outside. Would you say that this also applies in your case?
Yeah, so Helmholtz is a big research community in Germany, but obviously we have so many researchers who work across Europe, across international boundaries. This would absolutely help our researchers to connect within other people in their community and to collaborate more efficiently. Yeah.
Thank you very much. So, staying still in more or less in the same subject, I know, Xavi, that there's been an effort within the mesh to provide some sort of hybrid node which allows, let's say, mesh users to also benefit from escape functionality. Would you like to elaborate a little bit on that? And do you see this also as an enabler of possible, connections between communities?
Yes, exactly. So one aspect is connect people, but also another aspect is connect communities and different experiments and different sciences. One thing that is also evolving is the way we do science. Take the example of physics. We are running an accelerator at CERN. We are looking for a kind of the secrets of the universe, and we are colliding particles, but also cosmology, astrophysics, and radioastronomy. They are looking probably for the same things, like dark matter or other cosmological constants, and they are looking at the space. So the fact of having a place where the researchers can mix this different kind of data, collider data, telescope data, astroparticle, this opens a new scope, which we call multi-wavelength. You are looking the nature with different glasses. But up to now, it was very difficult for the people to have data from this experiment, from the other experiment, combine it in a visual way. We did something also with the help of LOFIRE, combining data from the radioastronomy, data from the optical views from the space. And this is just starting, and this is really something which should put the focus in the future. Also opens the door to this multi-messenger astronomy. There is one event, could be a supernova, then there is a network of experiments that will open the triggers. No matter what, they will record everything in short time. And then you put this in place in a kind of easy access for the people to do this combined analysis. And this is something which connects people and collaboration and experiment.
Indeed. Robert, yes, Robert, indeed. I know that you guys are also working together also with colleagues from WWU on essablishing some sort of project of effort which would allow Science Mesh to be bridged with HPC capabilities. Would you like to talk a little bit about that?
Yes, of course. So the main driving force behind that is Holger Angenent from Münster. You already mentioned the WWU, so that's the university he's at, and he's currently trying to bridge that gap. So basically try to connect our fast parallel file systems that we have in HPC more or less seamlessly or directly to Skibo or to a data exchange service that then can easily connect different HPC centers and avoid this problem of direct data give us a workaround for this problem of direct data transfers between HPC centers that we are struggling with. It's currently in the prototype stage, and probably you should ask Holger to talk about the details. But I think that's a great effort. It's nicely it uses a Nextcloud as a background service, directly connects to the parallel file system, and then exports that as basically something like Globus Connect in that sense, but something that we can maintain ourselves and develop ourselves and don't have to pay a lot of money to Globus for, and be a lot more flexible in how we use it and how we connect it to our HPC systems. If you have questions about the technical details, probably better to ask Holger. But if there are questions about the concept, how it's supposed to work, I can go into detail if that's
Great, thank you very much. So I don't know if there are any reactions from the panel to still on this subject. Otherwise, I would have actually one thing to I don't know, question for Wojciech. So you mentioned before that you're trying to take these tools which are currently using, that the researchers are currently using for their own data analysis, for their own job processing, and so on. And my question, maybe a little bit provocative, is, does this make sense? Does it make sense taking software, specialized software that is currently targeting researchers and moving it to education? How does it map in practice? In your experience, do people, does this end up producing, practical results? Is it user friendly? How do you see this transition from the research environment to a more educational one, where you're dealing normally with undergraduate students and do not necessarily master? As you said before, there's been this great evolution in usability of systems, but still there is a barrier, or is there not?
Yeah, I mean, they have to start with something. Yeah, to be honest, they are using the same packages as the scientists in data science, for example. It's all pandas, NumPy to operate on the data. It's all TensorFlow and PyTorch to train the models. Sure, there are some easier things to do. Maybe some solutions like platforms which allow you to just connect the dots and make the model for out of prepared segments of code. But from my experience, that does not lead to understanding any of it. So yeah, we just work with students from the basics, and surprisingly, there are some good projects after 2 or 3 months. Even projects which are deployed outside of Jupyter notebooks, they end up as Google Chrome extensions. For example, one of the examples is a project which recognizes a bad posture, of the person behind the screen. So yeah, good for us. So yeah, they are useful projects, and they are all starting from the point of knowing nothing, to be honest. So yeah.
So Andreas would like to pick that up.
Yes, thank you. It's an excellent question whether the technology you develop is not only relevant for science but also for other fields. And yes, it's absolutely relevant for education. But I might want to argue that like there's a lot more EFSS users, also large-scale EFSS users, be it federal institutions, and so for whom this may be relevant. So I urge you, move out of the scientific bubble, get into these other fields, into education, into federal institutions, and present what you have.
Citizen science.
Citizen science, yes, also, and this will also put your technology to the scrutiny of this large community of EFSS users, and this is a great thing.
Yeah, I would like to comment very quickly about exactly this. So the citizen science is something which is really expanding, and we have now the tools to really involve society. It's not only on the outreach and teaching, but themselves. But really, we run some projects on cataloging of galaxies, different type of interaction in neutrino experiments, training machine learning algorithms and AI, and involve society and students on that has a major impact. So this is really an aspect we should pursue.
Yeah, definitely. And how do we see then the federated aspect kicking in? Okay, we're talking about local things, right? You set up your own notebook, Jupyter Lab server, or you name it, and tell them, okay, let's install pandas, let's do some analysis. How does the federated aspect then get in? How can the Science Mesh add value to this?
Yeah, sure. Thanks for the question. I would say that there are some stars among the students who are really, really good at IT. Maybe they have some IT background. Maybe they are enthusiasts. And earlier in our boot camps, we had a really hard time bringing them together to work on some projects. And they are distributed among different schools. They don't know each other. And such initiatives as ours could bring them together and work on the same project. And maybe the project could be even better than those projects that we had that won our yeah. Yeah.
Okay. Yeah. Perfect. Thank you. Yeah. Very good point indeed. Maybe we can leverage on these federated aspects to make that possible. So great. So I suggested we start talking a little bit about the future. We're more or less halfway into our panel. So I would maybe start with you, Andreas. How do you see Science Mesh, the role of Science Mesh with regards to the future of HIFIs? Or let's put it another way, what would you like to see in Science Mesh that would help you fulfill your mission in HIFIs?
Yeah, so as you guys from Science Mesh at least know, we in Helmholtz are also working on federated sharing, but based on groups instead of user bases. And we also in our technology, we have lots of open questions, which actually you may be able to answer for us. So I see a large possibility for future collaboration, maybe bringing the two technologies together. And integrate this in a deeper technological level so that we have a sturdy base for collaboration cross-institutional.
Great, thank you. And I would ask the same question maybe to Robert. So how would you see, how can Science Mesh, which future improvements, developments would you like to see in Science Mesh that would help you in your own mission?
What would help us is to, on the one hand, focus on the whole life cycle of our terms of compute project, and but more importantly, make it easy for smaller institutions to connect to Science Mesh. Opened up. I mean, we here in North Rhine-Westphalia have the pleasure of having Skibo here, which is a part of Science Mesh, which does a great work for federated sync and share and so on here in North Rhine-Westphalia, but opening it up to users from, for example, all over Germany, because we are a national high-performance compute center. We are not just serving users in North Rhine-Westphalia, but all over Germany. And then you run into problems that if a user comes from North Rhine-Westphalia, they can use Skibo. If not, then not. And all this kind of things that block certain workflows. Especially, so to sum up, to especially make it easy to connect your own services to Science Mesh and to open up for also smaller like work group clusters, for example, that have maybe half a person or a quarter of a person as an admin, and still should be connected, but don't have the manpower to like larger projects have. That would be something really helpful for us.
I see that there's really a focus on the long tail, so to say, on the smaller institutions that don't have maybe the means. So, Xavi, would you say that it's the case also in your opinion?
Yeah, I think one of the beauty and the power of Science Mesh is close to academia, is close to universities, and thing is that the local groups, which are in my case physics group, they could be another science, that are closer to the institution. They have a node where they can find the needed pieces to do analysis and to perform their work. Now, this links quite a lot on the initiative, which are now, I would say, starting on analysis platforms, analysis facilities, multi-research environments. If these people can link this kind of personal, local place to work with the facilities, with the big science, with access to resources, with access to HPCs, I think we will really narrow the gap to enable these local facilities, local communities which are working in the institutes or physics labs to really have this kind of overview and this ability to get the data from different experiments and access different kind of resources, GPUs, HPCs, etc., etc. This is a long work, and it's not simple, but I think the pieces are there. We're just starting this kind of movement.
So, and in your view, the Science Mesh can then help bridge this gap, or?
I think so. I mean, Science Mesh, I mean, what I have seen, and you have the notebook as a platform. We are working on in virtual environments. You are bridging with local storage. You can mount external repositories like CPMFS. We see that there are some nodes that can be part of a data lake or can be part of distributed storage. So this kind of interoperability and integration, I think, is there. We're talking about protocols, we're talking about software, but this is basically coding and basically rowing into and agreeing in some kind of standards and protocols and technologies.
Thank you. Wojciech, so with regards to education and to your own use case at PSNC, then what would you like to see in Science Mesh do, which would make it easier for you and for your colleagues to do their work?
I mean, it's already easy, to be honest. Yeah, comparing. Comparing to all the things the data scientists have to go through and the graphical user interface that students are presented with, I think it's really easy for them to get around, to upload their own data, to make something of this data. Even after our classes, they are taught to make a project. We have a small competition, and they are bringing their own data to this platform. They are working on their own data, so we just leave them alone with our platform, and I would say that it's a great value, and that is a great point great thing to see.
Thank you. So we are already at the half-hour mark, more or less. So I would suggest maybe can we start with the questions from the audience? Would anyone like to participate, to ask a question to either of our panelists? I don't see any takers. So in that case, I will ask the questions. So let's maybe stay with you, Wojciech. There is, lots of hype right now with AI and machine learning. And okay, I don't mean to jump on the bandwagon, but still, it's something we cannot, as a topic, we cannot avoid at the moment. How would you say the Science Mesh, enables research in AI and students, especially how it enables them to play with AI and learn AI and machine learning? And I guess in this regard, the Jupyter interfaces are probably the most relevant component. How do you find that? Do you find it is helpful?
Jupyter notebooks really are helpful, and what Science Mesh brings to it is to enable the user to upload your data more easily. For sure, Jupyter notebooks are not the only solution. I mean, if you are going deeper into the project, you are abandoning Jupyter notebooks because you want to end up with some kind of repo which is consistent, on which code is refactored, and you can't have 100 notebooks. But to take your first steps to just see the data, to explore it quickly, it's a really good tool. And to be honest, sometimes I also use our platform to just upload the data quickly, not making data transfers through rsync to our data, to our HPC, and just upload the file and see within 15 minutes what's going on in the data, what's wrong, or what may be interesting.
Robert, maybe you want to step in here. Well, I'm saying this because we're talking about.
Let me. I also wanted to raise a point here. So sorry to interrupt you. So that's exactly one of the problems, one of the challenges that we have as a HPC system provider, is to bridge the gap. So I mean, if you look at your typical machine learning AI user, they want interactivity. If they want to start a Jupyter notebook and use a number of GPUs, they want it now and not in like 2 hours or 4 hours or at night at 2 a.m. when our scheduler in the HPC system says, yeah, no, there's resources free, but they want it now. And to bridge that gap of interactivity for smaller jobs, and then on the other side, large production AI, large language model, or other machine learning jobs that use tens, hundreds, or even thousands of GPUs. This is something where Science Mesh helps us in terms of bringing the data together so that in the Jupyter notebook, they can work on the data and make their first experiments with like a few GPUs. But not idling a larger number of GPUs on our HPC system while doing their experiments. And on the other side, when they come to the production style machine learning workloads, they have the same data provided by the same servers on the HPC system.
Works. So I understand this compute capability can be distributed across different nodes. So if I submit a job at a given node in the mesh, how could then this allocation of computing happen? How could the negotiation between the different nodes happen? Do you have any view on that, or is it something that will have to be defined in the future once we start getting, into that territory?
So in the mesh, this is not, as far as I know, not happening right now, and it's also a question if that will happen like this distributed way in the future. But on a just a two-level basis, where you have on the one hand smaller clusters with maybe some less expensive GPUs where people can run their initial tests, that is then for ease of usage, for example, directly connected to Skibo, and on the other side, having the larger HPC installations with hundreds of GPUs, bringing them closer together and connecting them via Science Mesh, not in a dynamic way that you maybe envisioned right now, but just in this stuff is, one side is for like smaller experiments, the other thing is for production style, bringing them together with respect to the data is something that Science Mesh can do and is already doing.
So we're nearing the end of this panel, so I would take this opportunity to just to check one last time if anyone in the audience has any questions. Okay. In that case, I would just ask the speakers for, if they have any final statements. Maybe we can do it once again a round table. Do you have anything maybe you'd like to say?
Of course, yeah. So about the topic of disseminating this technology, introducing more participants into the federation. There's always the possibility of smaller communities which may find it to be a bit daunting to join this large kind of federation. And maybe you want to, for the future, put some thought into having the option of multiple federations, maybe not even being dependent of a central federating component, but being based more on peer-to-peer technology. That may be very interesting, and as such, integrating this federation component more into the EFSS applications natively. That would be very interesting to see.
Right. Yeah, a very nice is peer-to-peer idea. Moving from, let's say, federated to decentralized, truly decentralized. Very good point. Xavi, would you like to go next?
Probably a final word is that we say this, the long tail of science and different communities, this long tail of science right now, I would say that this tail is not small. I mean, scientific communities, scientific experiments, and the different clusters in Europe, they are going into the direction that they need more and more common tools for data management, for data transfer, for analysis. And I would say, my desire would be that we work this together, we collaborate, we see which things we can do together, in which tools we can collaborate, and if there is a possibility to go hand in hand. This is a massive, I would say, effort that we will be saving, because if every community develops the same things or try to go in a different way, and everyone is paid or is funded for doing the same thing, if we do it together, we'll have probably less tools, much more powerful, and from the sites providing the resources, the computing, the notebooks, the infrastructures, the more common we are, the easier for them to put the resources and the manpower into the place where it's important. I'm talking about the ML, AI, and the future quantum, these kind of things which are outside the main mandates of a computing center, which probably is not maintaining end systems for data management, storage, etc. So the more we can talk with the communities, the more we can find commonalities, the more that we can pursue, like in these projects that we are talking today, EOSC, Escape, CS3MESH, the better, and we should keep this.
And just a provocation, and Rita is going to hit me for that, because making it longer, but would you agree that this is something that should be a grassroots and something that should grow organically? Because until now I've seen people trying to do that top down. What would you say about that?
We need top down to have the umbrella, but we need the bottom up. Is fundamental. One of the beauty of Escape is that things happen basically sporadically. There was the will to collaborate and talking to the scientists, having the PhD students working with these notebooks, having the community, the data management of the experiments, the people doing the analysis at the top level, at the bottom level is fundamental then to go bottom up, because then the top down approach at the end we will meet. If we only have one of the two, this doesn't work.
Yeah, thank you. Yeah, Andreas
wants maybe from a more technological standpoint, the way of making this broader may simply be standardization. So if anyone has the issue of federating EFSS and they look into the RFCs and they see, oh, this is how it's done, then this is how they will do it, and they will join the effort, and maybe this may be a route for you in the future.
I think that there's particular people in the audience that we would have to convince first. Can think of one at least. But yeah, very good point.
I assure you it's worth the effort.
Yeah, I completely agree. Thank you very much. Wojciech, any final statement?
It's hard to add something to what you said. I would only say that bringing those tools to the communities will result in really innovative projects. We see this among our students who come up with really great ideas about which we wouldn't thought about. So imagine if we didn't bring it only to the, I don't know, thousands of students, but if we brought those tools to everyone, we could end up in really good solutions, really innovative things.
Indeed. Thank you. And so we started with you, Robert, and we close with you.
So all I can say is basically that Xavier put it perfectly with combining efforts, because we have funding on the local level, we have it on the statewide level, Germany-wide, European-wide, and often, in my view as somebody who runs HPC systems, they don't right now don't coordinate and communicate enough to join forces, and that should be one aspect for the future, to combine these levels, make something great for everyone out of it, be interoperable, have nice standards, solutions that can be nicely used in small systems and very large systems, maybe have different focuses, and yeah, bring everything together basically.
Very much. And thanks a lot to Andreas, to Xavier, Wojciech, and Robert. So a round of applause for them, please.
So we have Milan Dashnek, he's from CESNET, and he's presenting from home. Then we'll have Elisabetta Ragozzina from CERN, which will be followed by, also from CERN, Giuseppe Lopresti. So I would like to call on stage my fellow colleagues, Giuseppe and Elisabetta. Welcome. And then just to provide a short overview, let's start with Milan. Milan works for CESNET since 2016. His main responsibility has been to develop close collaboration with research communities within the Czech Republic, and he also focused on supporting the specific requirements in the data storage area. Regarding Giuseppe Lopresti, so he works for CERN since the last 18 years for large-scale storage services targeting the scientific community. He has been contributing to development and operations of the tape storage system for the experiments at the Large Hadron Collider. Last but not least, we have Elisabetta with us, who has been working from CERN since the last 3 years in the storage team. She has been contributing to the front-end development and the UX design of CERN Box. Let's start now with Milan, who should be online. Milan, can you talk, please?
Hello, can you hear me?
Milan?
Yes. Hello.
Hello, we can hear you.
Yeah, perfect.
Welcome. So I'll kindly invite you maybe to do the presentation from your side, sharing your screen.
Okay, I will try to share the screen. Give me a second. Okay, can you see my screen?
Yes, we can.
Okay. So, good afternoon. My name is Milan Danicek, and I'm working in CESNET. And with my colleagues, we have been mainly responsible for the development of so-called invitation workflow, which is a part, let's say, very important part of the Science Mesh. And I would like to briefly introduce you the invitation workflow, and then I will show you short demo. So what is it, invitation workflow, and why actually we need it? There is a so-called Open Cloud Mesh protocol, which has been used to create federated sharing between sync and share systems. This protocol was already established before the Science Mesh project itself, and it enabled users to share their data with known users across the sync and share system supporting Open Cloud Mesh API. Known users in this term means that the originator of the sharing, so the person or user who wish to share the data, must know the target user system and the identity of the target user in that system. This is a bit inconvenient because there are cases where you simply know only the email address, which doesn't need to be necessarily the business address and so on. So we develop invitation workflow, which this invitation workflow provides a user discovery mechanism for the users. This workflow establishes the trust relations between users from two separately operated sync and share systems. And This invitation workflow provides invites, which these invites or invitations are sent via any textual communication like mail, chat, or any other preferred way. Once the target user accepts the invitation, the trust is established between the users, and the user identity is revealed to the originator, to the originating system. So the user which wish to share the data can simply find you in the context or in the search button and can start sharing. This invitation workflow is bidirectional, which means that once there is established trust between user A and user B, that the trust is also established in the opposite way, so that later on, for future purposes, user B can share also to user A. So we prepared a short demo, which demonstrates the invitation workflow between OnCloud 10 and Nextcloud. The demo is performed between two users, between Miroslav from PSNC using Nextcloud and between Milan, basically me from SysNet, using OnCloud. Miroslav wished to share the data with me, but however, Miroslav doesn't know what is my target sync and share systems, or where is my organization, what is my identity in the system. So he generated an invite. Then this invite he will send to me by email, and then I will click on the URL in the email, and I will reveal my identity during the acceptation process to the Miroslav Nextcloud. After that, Miroslav can find my identity in his Nextcloud and can start sharing data with me. The accepting of the invitation established the trust relationship between the users, and this trust relationship is used to share various resources. In our demos, it's used to show how to share the data, but it can also be used to share applications, and it will be introduced by my colleagues consequently. So I think that's the introduction, and if I can ask you, Rita, to play the video. Is that possible, Rita?
Is ready.
And please, can you mute it? I will comment on it so there is no background music.
Can you see the video?
Yeah, can you mute it, please?
Wait, I need to adapt the audio a little bit.
Okay. Okay.
Can you see the video?
Yeah, I can see the video, but please lower the volume of the video. You can mute it.
Sure. Can I mute completely?
Yeah, you can mute it completely.
Okay. So I'm gonna make play.
Perfect. Thank you. So now we are going to the demo itself of the invitation workflow, and I will demonstrate the cooperation between Miroslav from PSNC and between me from SysNet. So now Miroslav is going to log into PSNC Nextcloud by the federated using his federated identity. So now the login is done. Miroslav will now upload the data which he wished to share with me. So now he's uploading the dataset which he wants to share. Okay, the dataset is there. Quick check if it's complete. Okay, dataset is correct. And now Miroslav is going to generate the Science Mesh invite. So now the link is generated. He will copy to the clipboard, and Miroslav will send me this link via email, which is the only contact information which he knows. So yeah, he will compose the email with the invitation link. Perfect. Yeah, and he will send it. Good. Now I will go to my inbox. Well, I see I have new email from Miroslav, so I will click on the invitation link from the email, and I will be redirected to the Mesh Directory service, which is the service to choose my home sync and share system, and where I can perform the acceptation of the invite. So I will reveal my target sync and share system. Now I will log in into our SysNet service, which is on cloud, and now I will accept the invitation from Miroslav. So click. So it was successful. So now back to Miroslav. Now Miroslav can already see my identity in his sync and share system because I reveal it by the acceptation. So now Miroslav can share the folder to me. So now Miroslav will find my my identity. Good. So, and he can start the sharing of the data set. So now it's complete. Now back to my on-cloud at SysNet. I will check the files shared with me. Now I can see there is the incoming share from Miroslav, so I can accept it. And once I click on accept, I can see the dataset being shared from Miroslav. So it's finished. Okay, so that's all from my side. Thank you.
Please. Let's leave the questions for the end of the presentation of this session. In this case, I'll call Elisaveta to come here to start her demo. Oi.
No sound? No sound. All right. Hello, I'm Elisaveta, a software developer at CERN, working for CERN-Box. And I want to showcase the outcome of our work on implementing federated sharing between CERN-Box and an on-cloud infinite scale-based platform. Yes, so for that we integrated OCM layer, similar to the previous demonstration, into our backend Riva. So the first step is also establishing trust between two users, and for that, let me just stop. We implemented an extension that manages the invitations between users. So as a user who wants to invite another user, in my case it's me, who want to invite, for example, Albert Einstein to collaborate. As this user, I generate an invitation in this extension. I can add a description to this invitation. I can also enter an email of the invitee. And in this case, our system automatically sends an email to invitee. So I'm creating it and generating the token. You see that here I see the overview of all invitations. Albert receives these invitations. He follows the link that leads him to this Science Mesh directory. He selects his provider. In this case, it's Marineford, an OSIS-based platform. He clicks on accept, that redirects him to his platform, and he basically accepts the invitation. He can also select and manually enter some information. Once he accepted, we both appear as federated connections by each other, and we are getting notified that a new federated connection has been added. And now I finally can share with him. He can also share with me, so it's a mutual sharing possibility. So I create a share, select his account type as federated. Now I can find him here. I give him the editing access rights and share with him. And by him, in his platform, he can now go to his shares and find the shares that I made with him and basically browse through this share. And what else he can do? my colleague, sorry, my colleague Giuseppe will also show you. Yeah.
Oh, thanks, Lisa. Yes, so now we play the role of Albert, but of course I'm not Albert Einstein, but still. So the idea here would be to also, to show a bit also the added value on top of just sharing data, right? So in this case, the idea would be that I have this view and I dare showing it live so that we see it really like with the browser. So I'm actually browsing what I received from my remote colleagues. In this case, I have this shared science that these are shared with me. So what is the extra added value of Science Mesh? One of the values that we discussed already even this morning is that it's not only about data, it's also about applications. So I can also open this file using the remote application. So you see that here I'm at this site, which is my own cloud. And in this demonstration, Lisa belongs to a different site with a different prefix. So now I'm actually navigating into her system. And I'm editing together with her, and we see here that we are two collaborating. So she is the owner of this file. I am a remote user, and we can actually collaborate together on this editor. I mean, this is one of the many common editors that exist in the open source market to do markdown editing. It can actually be anything, in fact. I mean, this kind of process would work actually. So what we integrated is, as we mentioned this morning, Collabora on the Office as on-premise solutions for collaborative editing. And of course, I can type, and Lisa can type on top of me. I think she's even typing on mobile. Okay, why not? And yes, so then you really get the collaboration going across clouds. And you see here, we're not using any Google account, any Microsoft account. You know, there are no big clouds, no big data players. We are just sharing across the two systems that we belong to. So the two institutions to which we belong to. Okay, so far for the demo, and I will actually jump into some more slides to give a little bit of more context on this part. So yeah, let's go even. Let's work with the full screen. Yeah, that works. Yes. So yes, essentially what we discussed, what we demonstrated here, what already we discussed during the session is indeed trying to build on top of an existing layer, and the existing layer being what we call the OCM. So OCM is the Open Cloud Mesh standard. So I wanted to give you a little bit of context on that, also to anchor this into something existing, not just words or acronyms. So I'm going to introduce a little bit what is this standard, how we expanded it, and how we are looking forward into evolving this also for the future. So this Open Cloud Mesh, actually, this is a standard that exists already for several years, in fact. Initially, it was adopted, it was actually formed within the giant kind of framework or envelope, and then it was adopted by our project, the CS3MESH4EOSC project. And in fact, it's just a simple protocol to do vendor neutral sharing. So it's a way to share across multiple enterprise file system sync and share systems. So those are like on-cloud, Nextcloud are the prominent ones, but in principle this can work with any of these kind of systems. And the idea would be, so this existed already in the first place, so why don't we build on top of it? And indeed, and there are implementations on cloud and Nextcloud are the most prominent ones. So the idea would be to indeed build on top. So build on top, what does that mean? In fact, what existed in the market was a kind of preliminary implementation. And within our project, we managed to standardize to have a kind of a first official version at the very, very beginning of the project, and an extended one just a month ago. And what do we have in this standard? In fact, we have the sharing itself, which I call multi-protocol, and you already saw how it is multi-protocol, but I will give you a few more details in a moment. We have what we call the invitation workflow that has been demonstrated by Milan first and also by Lisa. So this is the way to establish a network, what they call a curated network of trusted users. Curated in the sense that here the idea is that you contact other users for which you know the institution, and the institutions are themselves establishing trust via this directory of trusted sites. And this would overcome the limit of just sending over an invitation by mail, which is like spam. I mean, you cannot really trust just an email address. This would be a way to have a trusted recipient for a share. And okay, some kind of discovery capabilities, because okay, those protocols expand and then you have to know what the other system is capable of doing. And so in terms of really technical endpoints, just to have an idea at least how this protocol works. So there is a discovery endpoint, where there is no need to get into many details there. Then there's this share endpoint that is actually how you tell a remote end, I want to share something with you. And this is actually what supports multiple protocols. Then we have the invitation itself. So with the principle that I send an invitation to somebody else via mail, via whatever I like, the recipient will send me via this endpoint, so via OCM, the fact that, okay, they accepted it. So we are ready to exchange information over the two systems. And then there's also a notification endpoint that is actually there to notify about changes. So I want to change the properties of a share, I want to actually drop a share or whatever else. And in fact, for the specific details, those protocols, what we call protocols, are actually the way by the protocol, by the OCM exchange, to describe those two most important added values. One being the applications, like we just demonstrated, and the other one being the data transfers that Ron described early today. I will concentrate here on the applications because this is actually what we have demonstrated. And so here, really, the model is it's kind of simple, but you have to already split it into multiple layers. Because one thing is that you share as a site some data, but also some services. And this can be anything indeed. I mean, we demonstrated with an editor. This can be Jupyter Lab platform, can be really anything. But it's conceptually a different resource compared to the data, right? So those two go via different transports. And the recipient, the remote user, should be capable, and it is enabled actually, to either browse the data, and this is typically via WebDAV, or also access the remote application. So it's given a link. That's why I'm really giving a link to navigate into my colleague's system, and so that I can interact with the other system. And this is how then things work. And of course, if I have also my local application, I have to be careful in not making it collide. I mean, ideally, I want to use the remote one to collaborate. But it can also be that there are cases where I want to use my local application. Why not? So this is a little bit the context and the principle how we are building on top of OCM. So OCM is just there, and this is a kind of added value on top of OCM. And a typical question that we got, and I want to kind of reassure, is that it's clear that this is like exposing services, so potentially there are licensing issues. But at the same time, what we see typically with those systems is that they already offer what we call public links, which is exactly the same like we have in Dropbox or in Google Drive, where you have a link which is anonymous and can be accessed anonymously. And so this is in a way something similar, where we have some kind of authentication, but effectively it's a kind of anonymous link. And typically applications are already enabled in those public links. So after all, even vendors we have been in contact with the typical vendors in this case, like Collabora or OnlyOffice. They already support this kind of model. So it's not really breaking very much the licensing principle of those providers, let alone the fact that platforms like Jupyter Lab, they are anyway on the open source. So it's kind of logical that they are even more open in this way. So to summarize, and so you see that here the goal and then the key is really the sustainability. So OCM is there, it's already implemented by the vendors, And we are just building on top to provide those, what I would call added value services. So applications on top. And what is coming next is that, well, at least the good thing of this project was that there has been some renewed interest. There is even one partner, well, not really partner, it's a contractor, but is partnering with us in doing some developments that that went the extra mile in asking for more funding and keep the wheel going in terms of how the standard itself can evolve and how can other features can be added, for example. So I would actually expect that once all of this is really deployed at scale, and we are still at the kind of commissioning phase, so this is really being installed, that then more things will come because of the user, I mean, how the users will adopt it, essentially. And with that, I thank you, and I guess we can go to questions and discussion.
Thank you. Is there any questions from the audience here in Poznan? On questions?
Solution is encircled the bottom left, and that is about a web of fair data that is going to solve the issues around fair data and open science. And that's the whole idea of the EOSC, that you have a set of services centered around services that provide you with data. Okay, and in the meantime, this European Open Science Cloud also has an architecture that are you have, let's say, the EOS core, where you have the core services and policies and procedures that you need for the whole infrastructure. When you think about rules of participation, security coordination, help desk, what is it, AAI, things like this. Then, of course, you have the EOS exchange layer. Those are the services that interact with this open data, and there they envisage a number of pillars that are, let's say, either regional e-infrastructures or e-infrastructures that are centered around scientific user communities, each having their own middleware, portals, dashboards, and what have you. On the left-hand side, there is the support activities, and on the right-hand side, the interoperability framework to make sure that everything is able to talk to each other. Now, about this project, the CS3MESH4EOSC, that stems from the CS3 community, and the CS3 community consists of a number of sites that run sync and share services for their own constituency, their own people. Once every year, we meet at our yearly meetings, and well, the last one was in Barcelona, organized by Gideon. Thanks, still Gideon. What we also do during these meetings, we fill in a survey, and it appeared that, let's say, last March at least, that there were something around 20 sites available there, and altogether more than 600,000 users, which is a hell of a lot. So where we started with, so to speak, with already existing sync and share services that are already sustainable, financially sustainable. They do not rely on European funding at least, but only on national or institutional funding. Join together to, let's say, federate the resources and to enable users to share data and services. And that's what we call the Science Mesh. Of course, there's a very lightweight central component there, which contains the central services like help desk, monitoring, a site registry where all the sites are listed, usage metrics, and the like. And the rest is just, we have just a number of sites. And of course, these sites can already exist without the central component. if that were to be if that would be down for a day, it would not be much of an issue. It would only be problematic to add a new site or to remove a site, but the whole infrastructure would just function normally. So it's a very lightweight component, which is not critical for the operations. Okay, well, over the last, we started with our sync and share services at SURF in 2014, and most institutes started around that time, or maybe a little bit earlier then. Since then, and then you talk about the 2013s, 2014s, so on, let's say the on-premise and also cloud-based sync and share services have increased steadily, and I'm not just talking about the big guys like Google, Microsoft, but also things like Ignite, P-Cloud, the Box, and there are a gazillion EFSS service providers. Most of them are in the cloud, but some, like also OwnCloud, Nextcloud, provide also sync and share services that you can run on-premise. And of course, I've just also been discussing the user numbers that we have. These services have become quite popular. And why is that so? Because they are so incredibly easy to use. It's a very low threshold for people, even people that are not really tech savvy. They can handle sync and share services. And the good thing is that wherever you go with your laptop or your tablet or phone, you get your data with you. You have always access to your data. It's also easy to share data, not only with your direct colleagues, but also inside, outside your institute, whatever you want. And that is also a development of the last number of years. Although a lot of these services just started out as Dropbox clones, let's say there has been a lot of effort into, let's say, to integrate those kind of services with, well, let's say, all kinds of business applications like Salesforce, Zoom, Slack, Atlassian Suite, what have you. But also, let's say, in the science domain, and we've also been discussing this today, like with just Python notebooks, Moodle learning platform, and the like. So this is also a very important thing, that you can integrate these services with all kinds of other stuff that is useful, and not only integration with other services, but as we've seen this morning with the integration of Escape and the Science Mesh, also integration with other e-infrastructures. Okay, and it is expected, because I also need to explain this picture, of course, that the enterprise file sync and share business is going to grow up until something like $26 billion by 2027. So the growth is still there. So yeah, where do I see the Science Mesh? And that's the let's say the European Open Science Mesh Cloud is I see the Science Mesh just among the horizontal services that are there and play their part. So reason for that is that, of course, it's not the horizontal services are those services that are not really related to a particular type of user or user community or whatever. This just for the general public, and that's exactly where these sync and share services are shining. Difficult sentence. Yeah, what is the good thing about this? These services have the potential, as I've already discussed with you, to reach an enormous amount of people. I mean, just now we're talking about 600,000 users. Now, not all of them are researchers, of course, but if you think that in the whole of Europe there are something like 1.9 million users, means that these services can, let's say, reach a large portion of them. And the good thing is we already talked about integration with all kinds of stuff. These services can also integrate with services delivered by EOSC. which means that these services have the potential to, let's say, bring EOSC to the masses, not just the certain user communities or things like this, but just everybody. And that's also a good point, because you as a user are just using the sync and share service of your own institute, and then immediately you should be able to access resources from EOSC. Well, it doesn't get any cooler than that. So, let me see, yeah. And of course, yeah, there are also users that do not directly have access to EFSS because their institute or whatever does not provide it to them. But there are also other options. I mean, and a lot of sites have a sync and share service just for their own organization or let's say the collaboration they're part of. But of course, there are also partners, or at least potential partners, that have that are allowed to deliver these kind of services to a much broader audience. So those kind of services would be a way in to them to use the resources of the Science Mesh. Currently, there's also a procurement in progress. It's called the Managed Services for the EOSC platform, and there's a lot 3 which deals with enterprise file sync and share services. And of course, this procurement will be won by a consortium or an organization. And of course, through the winner of that procurement, it's also possible as, let's say, what we call a homeless user to be able to use the resources of the Science Mesh. Yeah, I'm done.
Thank you. Any questions for Ron before we go to the panel? Any questions from online?
No, everybody is looking forward to the panel.
And we were very clear in your presentation. Thanks, Ron.
You're welcome.
So a round of applause to Ron. Okay, now it's time to start our second and final panel of the day. So I would like to call on stage the moderator of the panel, Guido Adben, who is a senior international strategist officer at SUNET, the Swedish ANREN. And then we have 4 panelists with us. The first one is Andrea Cristofori, data solution architect at EGI. So welcome, Andrea. We will welcome you to come on stage. Then we have the CS3MESH4EOSC project coordinator, Jakub Mosiski, who is also from CERN. Then we also invite on stage a person who was not here before. He is Gideon Vandenberg. He's a research and project manager at ESADE. And last but not least, we have 2 online panelists. One is David Antus. He's the head of storage department at CESNET, based in Czech Republic. And then we also have Christy Holmes from the United States. So she's presenting, if I believe, from Chicago at this moment. And she's the director of Galder Health Science Library. I see on stage Kuba, Gideon, Andrea, also Guido. And can we listen also from home, David and Christy? Would you mind to talk to us? Andrea, David, Antus?
Yep. Good afternoon.
Hello, good afternoon. Welcome. And then now, Christy Holmes?
Yes, good afternoon.
Hi.
There you are. So they're over there. Ah, there they are. Fantastic. Wonderful. Both of you.
Okay, it seems we are ready. Guido, over to you.
Wonderful. I'll take it. So, question of order. Is this still the prank laptop that can fall down? No, it's the other one, right? Okay, because I break everything. And the second question is...
Don't touch, please, then, if you break everything.
Okay, won't touch anything. Won't touch the subject.
Put your hands down. That's not necessary.
You don't want me to do that. So what microphones do we use? We've got 2 on stage. Can I use that one to walk around with?
Of course.
Wonderful. Thank you very much. All right. To set the stage, and riffing on the description that Ron gave about the premises of the project and how we think it's going to pan out, at the same time, most of those conceptions were, we came onto those conceptions about 5 years ago and drafted the whole proposal. Surprisingly got funded, yay. But that was 4 years ago. And you know how it goes as a project, you go nose down, you hunker down, you start developing. Then we were hit by COVID, which made it into an even more sort of isolated effort. And now we emerge, we're like 5 years after the first draft of the tenets. It would be hubris to think that nothing has changed. I know that we've had a bit of scope creep. We haven't delivered precisely what we said we were going to deliver. And meanwhile, we're delivering to EOSC, which itself has shapeshifted a fair bit. So we thought it would be wise to ask a few people who have had exposure to the wider audience, the use cases out there, how the environment has shifted, because we don't do this in splendid isolation, and those people who have some contact with where EOSC is going and where internationally this is going. So we thought we'd throw a few questions at them. And I had trouble figuring out whom to give the honor to, because they're all luminaries, like the nicest person in the world who organizes conferences, person representing the people who organize this conference, boss, my boss. And then there's two people who took the trouble. Can we get them back on stage? The heads. Oh, you're doing this. Well, I'd like to have the heads of the people on the. Yeah, there we go. So two people who actually took the trouble to arrive virtually. David, thank you. But I think the greatest honor goes to the only non-European in the room, who took the trouble to talk to Europeans. Thank you for doing that, Christy. Would you mind if I opened the debate with you?
Sure, that sounds great.
Oh, because for you, it's what? It's 5 a.m.?
It's actually just after 9:30.
Oh, still a lot of respect, but a little less. So we've got you here because, first of all, you're a non-European. That gives us, that stops us from navel-gazing too much. You have a view on what has been developing and how useful that all is. Secondly, you're in the medical field, who are a crowd that's hard to please. So anything that's developed, if it's not properly useful for a researcher, you will know this as one of the first canaries in the coal mine. And the second thing is, you have proven that you care about international collaboration, given that you're on the Invenio RDM development team. So there's two questions really I wanted to ask. First of all, assuming that you're relatively aware, somewhat aware of where this whole EOSC thing is going, can you see parallels between what's happening here and what's happening in the US? And if so, which of the ones that we're doing is useful to you, and which of the stuff that you're doing should be better known here? How can we intertwine the two?
Sure. So I will attempt to answer this. I think, as you mentioned navel gazing, and I am very certain that the people in the United States are also navel gazing. So first and foremost, perhaps one of the most important things that we can do is to work with one another, be able to foster more international collaborations that are genuine and authentic. I think so many times bureaucracy gets in the way and it limits our ability to actually dig in and do good work together. And so I've been absolutely thrilled to read more about what's happening with EOSC, and certainly think about it in the context of what's, our very young attention to open science at a much broader level. And I can see that there are a number of exciting advancements that are happening within EOSC that I certainly think that we in the United States can take advantage of. I've said before that sometimes the best way that I can seem like I'm really paying attention to what's on the horizon is just to look to the European Union, because I do think that because of the structure there and some of the other contexts, there are more opportunities for collaboration and kind of cross-domain and cross-national collaborations that actually result in real work. I'm sure that there are things that are happening here. Certainly there's been, I'm on the leadership team for our Augmented Intelligence and Medicine Institute. And we are really excited about some of the technological advancements that we've been able to do, and how do we think about being able to do this work in the context of a more open ecosystem, doing AI and machine learning, which has been, there's been a huge attention to that, obviously everywhere. So, I wish that I could bring to this conversation some this brilliant statement about how we should all be working together and what we can bring to the table and what you can bring to the table. But I guess what I would suggest that we all do is to come together and, open up those channels for dialogue so that we can learn from one another and see where those collaborations make sense and where we can begin to grow, the larger ecosystem together.
To throw a curveball at that, I think it was Zbigniew Brzezinski who, thank you, I pronounced that correctly, absolutely did. There's 15 paws twitching right now. Who at one point in time made the remark that you can't deal with Europe because you can't pick up the phone and call them. We're in the strange situation right now, I feel, that it's become hard to pick up the phone and call the US. Who do we ring to get a grip of coherent policy around where research infrastructures are going? I can see excellent work being done on a university by university basis, but whom would you recommend we liaise with on a regular basis to figure out where the ship is sailing?
That is a tricky question, so thank you. I will suggest that there are a number of important initiatives that are happening at the federal level. Certainly, we've had a renewed emphasis on open infrastructure and open processes, particularly from the White House Office of Science and Technology Policy, with some of the open policy mandates that are coming down the pipeline, the first of which landed at the National Institutes of Health in January. And that's really, I think, brought an incredible amount of attention and enthusiasm around some of these open science topics. Certainly NASA is very early to the game. They're really leading the charge with open science in the United States right now. So I do think that there are those individuals and certain organizations who can be that champion, that advocate, the glue that brings people together. There are also, I think, good opportunities for cross either domain or national dialogue. For instance, in July, there is a NASA CERN Open Science Summit. And so we'll see a number of people coming from many different domains, from our side of the pond and yours, getting together to talk about meaningful progress to support open science. So I think, providing more of those opportunities where we can get together and connect is important. There's a huge amount of attention at the federal level on this. So it's really about thinking about how do we want to make those connections, and then providing the opportunities for real dialogue, many times face to face. It helps to build trust, helps to build teams in a better way that can be more productive. And I do think that there's a large amount of interest and enthusiasm here as well. And, not that I certainly can't speak for the entire United States for sure, but there are folks that we'd be delighted to help to make those connections with.
No, fair enough. Sorry for that dig. All right, thank you. Moving on to our next remote speaker, David Antosh. I'm sure I pronounced that correct as well.
Yeah, excellent.
Twitching as well. Sorry about that. So, not only are you a member of the CS3MESH4EOSC project team, you also sit in on one of the TFs of the EOSC Association. Am I right?
Yes, I was volunteered for that.
It's the long-term data preservation TF, isn't it?
Yeah, indeed.
It is, right. So what intrigues me is that the project that we're running here has the potential to hoover up a lot more of the born digital data that otherwise would get lost or slip to grey IT or sit on NASA's under desks, etc. But that means that we we also have, we present the danger that we present a greater influx of data that needs to be preserved in the end. Do you agree with me up to that point?
Well, yes.
So the point is that typically what funders like is data that can be linked to a peak science funding stream or experiment or the typical curing childhood cancer, healthy aging, etc. They love to fund that. What we seem to represent is enormous amounts of, as of yet, unclassified data. And we're about to move that into long-term storage or present it to long-term storage. Have you heard inside of your TF people talk about what sort of merit allocation mechanisms need to be applied to long-term data preservation? Curveball?
Yes, I've heard people talk about that, well, first there is a slight disclaimer because the outputs of the task force are under review by the EOSC Association, and before they're approved, we are not expected to present them. So everything I say is just my personal opinion, and I would like to ask you to take it like this. Anyway, the difficulty is that the task force hasn't actually discussed the processing of the data and annotation of the data. The task force mostly focuses on recommendations for data repositories, which is not only another league, that's probably another sport in data storage. So I'm afraid that there is no meaningful way to answer that, because the data must be reasonably annotated, equipped with metadata to be stored in the repository, which on the other hand should not be the cemetery of data, the final resting place. It should be a place from which the data is again taken up for processing. So I think that nobody has answer for this at this point.
All right, fair enough. But an analogy that you could draw is if you aim to preserve data for very long and you do so with the intent to eventually mint it for useful nuggets, you know, your future Nobel Prizes, then it's somewhat akin to an insurance proposition. You're insuring against a future event, but you don't know which event it's going to be. And the answer typically, oh, look at that face. You don't like this question, do you? And you don't quite know what the event is going to be. If you knew, then you would actually build fire breaks around the house that is going to catch fire. But what nobody does is insure absolutely everything against everything, because then you're basically bankrupt. So is the TF avoiding this question? How are you dealing with this in Czechia? I know you're the head of the storage department. You must have an opinion about this. If you don't answer this one, I'll stop teasing.
There were two questions. How we handle this? We built a platform to operate data repositories, and we are pretty well aware that this is a serious problem that mostly needs people to get educated about handling data, to build an infrastructure that consists not only from the technical part of things, but also from people who are trained to be reasonable in handling data and to act as data stewards. And we basically offload this question to them. And we probably lost you.
You say there. Oh, sorry, I thought I interrupted you. Okay, I'll repeat. What we're building here is essentially a data hoovering system, right? It makes sure that data that's born digital gets hoovered into a proper data managing system, rather than people dealing with it on a side-by-side basis and it potentially being lost for well-governed IT. Are there things that we can do to help the policy people that you just described? Are there mechanisms by which we can mark particular data sets or pre-nominate, or do you have recommendations for the system that we're building here to make sure that it allows those policy people and their funders to better recognize the data that's coming out of the system?
Well, I don't think it's possible to do on the infrastructure level. I'm afraid this must be done by the user communities who have understanding of the meaning of the data. It's very difficult to say from my perspective. I store a lot of data I completely don't understand, and that's my role as an infrastructure to handle the infrastructure part. And there must be another role for people who are able to mark the data sets that really are important and should not get lost. I don't think that there is a silver bullet to solve this issue in general, and I believe that the only recommendation is invest in data stewards who need to understand the meaning of the data.
That's fair enough. I'll park that for the moment. I'm sure we'll get back to it. Kuba's scribbling frenetically. There must be something in his answers right there, but we'll get to that eventually. Andrea, would you mind if we move to you? Because you're the Data Solutions Architect at EGI. That's quite the day job. Can you, Kuba, oh, you're giving him the microphone. Wonderful. So the main thing is, I know of no organization besides EGI who have better contacts in the Brussels area. And one of the most interesting things to come out of Brussels after we started this project was this whole concept of the data spaces. It sounds like it might be a match. It also sounds like it's way too lofty to be a match. What's EGI doing to position itself, and what recommendations do you have for what we're doing here and how the whole thing could be a fit? And take half an hour.
Well, okay, it's a bit difficult to...
I know it is, sorry. But it's so intriguing, I had to ask.
Yeah, okay. Trying to put together all different type of data and anything. Okay, like with the Science Mesh is a very good opportunity, I think, because you're trying to connect. Trying to connect all different EFSS. So is a very good thing. There is of course interest in that. It was mentioned before that there were also a project with AI that. They might require data of different type. So, okay, there is interest in that, and there will be more in future for sure, because, okay, a lot of data that is stored in different institute should become available, and probably through also the THESO project put together and analyze together. So all these data spaces, I see it like coming together, but not in only one place, coming from different places, connected together, and in different combination, depending on the project, on the research that is being done. And okay, I don't get exactly the data hoovering that were discussed, because most of the time probably the data will remain in the institute where it's produced. They will stay, but then the researchers will just want to access it from time to time, or download a part of it to work and build something new. And I agree that is difficult to understand what is the data that is important, because it's really difficult for a non-expert to define what is important, and then it might be important even for an expert, but it might be too expensive to keep everything.
Oh, yes.
So it should be balanced, what is important and how much should I spend to keep it available. So yeah, I think is complicated.
Yeah, very true. So in a very short explanation, the hoovering part is the sync and sharing. The syncing part makes sure that the data that lives on laptops, etc., gets synchronized to more central locations, which I know must sound like a pedestrian thing for people used to the sort of level of EGI, but very often in the long tail of science, a lot of data is produced locally. And then only by the time people realize that a petabyte is a lot to move, do they go, oops. Okay. So when you're able to move that stuff as it's being generated, so facetiously we tend to refer to that as hovering up the data before it becomes a problem. Okay. Does that change your answer?
No, not really, because I was thinking to that as a kind of a granted that it doesn't sit on my laptop but is in the data center.
See? Naive assumptions. The tool you like to use is not the tool users use. In fact, I've sometimes made the remark that if you see a user ram in a nail with the heel of their shoe, give them a stronger shoe. Don't try to lecture them about pop nails or whatever. It's not going to help, right? That's just, users are a special breed. Mm-hmm. So the second part of the question is, governments have a tendency to allocate funding to organizations proportionate to the size of the funding. The data spaces are billions. How is EGI positioning itself to make sure that that doesn't end up with the usual suspects? I won't mention names, but there is a tendency to chunk that up in maybe 4 bits and give it to people who can handle 1 billion. I don't know whether EGI can handle 1 billion, but oops.
No, probably not. I don't know.
You know what I mean, right?
Can tie it together and then we see.
Yeah, absolutely. Oh, somebody's Italian.
Accept the challenge. Well, okay, we were trying to give all the opportunity to all the participants, and as participating in a different project, I've seen that we're trying to give to use resources from all the participants. Of course, there are some that are bigger, and then they might participate in more projects, and they might then end up with a bit more funding. But still, they tend to be fair in a different way as the fair data, but to allow all especially even the new participant that might have just joined to try to make them part and grow with everybody else, so that they can shine with everybody.
Yeah, wonderful. Not an easy job, but be honest. No, we do the good work, EGI. We rely on you. All right, moving on to Kuba, men of many hats. Head of the storage department at CERN, head of this particular project, also in the interoperability TF, I believe. I had some questions for you, but you were scribbling so furiously that I wonder whether I should be allowing you to answer your own question. Which one is it?
Well,
on Polish pronunciation?
Here I'm with the hat of the TF interoperability of the EOSC association. However, I can't help of remove, it's not easy to remove the hat of the project coordinator, and part of the job description of a project coordinator is to have an opinion about everything. So I wanted a little bit maybe to relate what Christy was saying and David.
Is any of us?
Allow me.
Is any of us in trouble?
No.
In that case, go ahead.
So
I don't care.
For Christy, I think. Well, I had two thoughts when I was listening to what you were saying. Maybe one mechanism to enhance, somehow to incentivize a little bit more the collaboration across the Atlantic would be to use some funding platforms which has specifically been designed to do that. So, for example, I'm thinking of NGI Atlantic, which probably is something that ended this year, but it's maybe it's a good example of something that we could try to exploit in the future. We've actually in our project we were thinking about that. I remember
we went further than thinking.
Yeah. So there could be some opportunities along these lines, and then of course what you are doing with Invinio RDM, essentially, this is a wonderful example of you identify a need in your user community on some service that you want to provide, and essentially we collaborate based on very concrete services that on both sides we find useful for our respective user communities. So I think definitely there's a lot of space and different possibilities and pathways how we could try to strengthen this relations. And so I don't know if you agree with that, but I just wanted to share a remark. And for David, for the preservation, you know, we also have a lot of discussions at CERN about preservation. And my personal take on preservation is that it suffers from the same problem as for metadata annotation. Essentially, it comes as an afterthought, typically, at the very end of the research, life cycle, data life cycle. And essentially, this is the moment when it's already very late or possibly too late because essentially once you publish your result, you're so much relieved with the fact that you've achieved that you are probably not so much inclined into looking into kind of secondary things like this. So one of the possibilities within the Science Mesh is to try to enhance the workflows that we propose, like we are doing for firm metadata annotation. We try to bring it earlier on into the data research data lifecycle, and something similar could be done for data preservation. And here maybe the technology could help, because a lot of systems around data preservation are based, for example, on containers, where you, as a way of capturing the applications and also maybe some smaller data sets. We also have an active discussion at CERN right now how to provide the next generation analysis facilities and also how to evolve our computing model, essentially. So something like, trying to evolve it from massive batch job queues into something maybe more based on containers. So maybe we'll have an opportunity as well here, if our analysis platform evolve and are kind of convergent with a technology that is also used for preservation, that it will be a very, very easy and natural technical, capability that we could exploit, this convergence. And then for data spaces, well, I can't help of not thinking about data lakes, and I'm trying to figure out what the difference is.
As soon as you know, it strikes me as, but this is just my view of things, it strikes me as something that started in policy and is slowly trickling down into, can I say reality, but at least implementation. We're not there yet. So as it trickles down and as the EC itself is beginning to find who its partners might be, but then there is an onus on us to make sure that they don't drift into people who tell them that everything is possible.
Yeah.
There's a lot of snake oil and emperor's new clothes, etc. And before you know it, it's 1.6 billion pissed up against the wind with another beautiful platform that never sees the light of day. But oops, that was a bit negative. Scratch that out of the whole recording.
No, but you're absolutely right. And I think the role of our community is to ensure that we provide solutions that are used by the users, by the researchers, and then whatever new concept comes in, it will be much easier for us actually to get hold of it in a sense.
Yeah, actually, on that, given that there's the largely positive development of the EC itself, so rewarding this idea with a pride of place in the procurement. The EOSC procurement action, which will end up with the EC owning a large EFSS system, which is good, mostly, but also means that we do have to influence them into the right direction, because the lay of the land. Community has a tendency to form itself around the biggest funded thing in the middle, right? CERN knows this. You have a fairly big funded thing in the middle. It does mean that we need to make sure that they make decisions that we think are clueful. I mean, they are the EC, they are clueful enough, but it's not their primary mode of existence, right? Running a system. So, do you have any ideas about that? Or do you want to ponder that for a while we go to Gideon?
Yeah, maybe. What exactly is your question?
It's out of form for you. You can just grab this one and turn it into whatever
Okay, I'll try to make something up from this, and let's give.
By September, there will be a central a node of an EFSS, rather well funded, that notionally runs all the protocols and interoperability standards that we believe in. But it doesn't itself have any governance. It's the EC running it. Notionally, by the architecture diagram Ron showed us, but that thing as well is 3 years old. So where's that going to go? How do they influence this thing? Do they take their governance from the EOSC Association? Who knows? So it's still not a question, but
Yeah, but okay, so essentially this is a question of sustainability. And I think then we have to look into the bigger picture, because if that node, and I think the idea is that that node is part of this, is a Science Mesh node as well, so essentially it will be one of many nodes which are provided as a part of Science Mesh. We know that the nodes in Science Mesh that are provided by existing nodes, institutional nodes that are provided in Science Mesh, they already have a sustainability model because they have a very large local user group behind. Okay, we are running CERN box at CERN because it's used by 15,000 people. Okay, Surf is running Surf Drive and Research Drive because it's used by I don't know how many, 60,000 or whatever, and similar story for all other nodes that we know of. That node, the EOSC node, well, we'll also have to find some kind of a model, sustainability model at the end of the day. So if there is a big uptake of that at some point, probably people will be, you know, if you get enough critical mass, probably it will make sense that people will, you know, it's a real resource that you're offering, right? So it's nice to offer a real resource for free, but at some point, you know, it depends also on the scale. At some point, maybe you want to do some costing of that. I don't know, but certainly there must be some kind of economical model that could also be related to the you know, to the, let's say, business model or economic model of the companies or the industry that is involved in this, like OnCloud or NextCloud. Because at the end of the day, maybe for them it makes sense that they run this service because this is the way also to kind of aggregate, you know, get enough of a critical mass for their technology also to expand towards other markets or something like this.
Yep.
I don't know, I'm just speculating, but...
Fantastic segue onto our next speaker, because he said business models.
Yeah.
And everyone goes to sleep. No, well, not so much that, but everybody knows that everybody else is trying to wheedle out from underneath that. And you guys represent the people with the nous and the sense of what actually works and doesn't. And you're in the researcher engagement TF, aren't you? Or is that Angelo? You guys in the broader sense.
Yeah. So for the record, I'm not in the task force. So take whatever I say from here on forth with a pinch of salt.
Shall do. But you guys are the reality check people for us. That's the reason why you're in the project. There is a tendency, as I'm not gonna bag you for it, Andrea, but the fantastic remark you made about, oh right, users don't behave like I do. It's something we have all the time. Like, and then you give them the command line and everything is rosy. So we have the people from SRIA in this project for that broader view of what's sane, what works, what do researchers actually do. So having been in the game of researcher outreach, science communication, etc., other things, so let's start with the self-congratulation. What is the stuff in this project that you think made it work? What could work from a user engagement point of view, and what could work better? What are the threats? How could this go off the rails?
Sure. You know, I think in the context of the Science Mesh, well, let me back up. I think I was reading a little bit earlier about EOSC, and, you know, I'm very new to that space, and one of the overarching principles of EOSC, you know, is that research has to be at the core of the initiative, right? Which means that real deep engagement with research communities is needed. You need to understand what are the needs, what are the requirements, and make sure that how EOSC operates and the services it provides serves those needs, right? Your specific question again?
What's going right here? What might go wrong? And if you want to take that to a broader context, I'll spike it a bit. If you've seen the architecture diagram for how EOSC is supposed to work, then the democratized stuff that might hit every researcher, is sort of hidden in the middle as a glue layer. Like CS3MESH sits in the middle as a glue layer. And the way clearly the EC itself thinks about researcher engagement is spikes high up, thematic portals that actually hit particular research cases. That works well for those cases that you manage to get funded. Right? And some of them are always popular in particular points in time. There's always some, you care about climate change, it's in there, right? There's always something about peaky medical stuff, not broad medical stuff, that's unfundable, but peaky medical stuff, that's always there. But you can't really reach all researchers in a broad outreach sense by doing all kinds of pinpricks into the research landscape, and yet that's the way that typically funding is thought of. But at the same time, we pretend to be building a cloud here. It's a democratized thing, a cloud. You can tell because the clouds that we used to try to emulate in the broader sense were sort of the competition. There was a degree of envy, like why are the hyperscalers so successful at scooping up researchers, and why is grey IT so successful? Can't we counter that? You might be able to counter that by having a democratized initiative that, a tide that floats all boats. And yet, inevitably, the funding structure is again moving back to funding peaky stuff and dealing with the horizontal broad stuff as an afterthought or as something that's sort of in the middle of the layer cake, not the prime thing that we do. So on the one hand, we care about user uptake. On the other hand, it's not really what we fund. How could that be done better?
You did not simplify the question, you are aware.
That's because it's frustrating, but it's so close to how funding bodies work anyway. And you guys are a business uni, you might know, or you might not know.
Yeah, I think it's the second.
If there is no answer, then at least I feel less frustrated. To know that somebody has the answer and nobody's asking them is even more frustrating. But
yeah, I mean, I think people are definitely thinking about that, but I'm not sure if there's a coherent answer.
No, it's hard. How do you structure funding in such a way? How do you incentivize policymakers? How do you incentivize people at the government layer to think of funding that does not end up in a ribbon-cutting ceremony for a bit of research that is to be done in 2 years' time? How do you incentivize them to not only fund that? They'll always do that, but not exclusively. How do you incentivize them to turn something like an EOSC into a properly broad-based infrastructure that scoops up an enormous amount of users and lives on the strength of its user uptake, not its peak science? So you're the only one I can ask. I know I'm putting you on the spot. Nobody else has, well, Christy might have a decent answer here, but nobody else has a decent answer for this. Not even you, Kuba.
Well, but I have an opinion. I have an opinion.
No.
Yeah, well, I mean, in this task force, for example, I mean, you're alluding to sort of long-tail research, right, and how we can... So the nice thing about this research engagement and adoption task force is that, yes, while we're looking at specific structured research communities, its activities are organized by organizational level. So there's a European subgroup, a national subgroup, and an institutional subgroup. So the idea is that the task force should expose research and capture the perspective of long-tail researchers as they engage with these different bodies, right? So I wouldn't say that we're missing the perspective of long-tail research. It's just about, what after that.
Yep, no, understood. That's fair enough. Rita, how much time do we have left? None? It should be over now. That's harsh. This whole thing should be over now. None. 4 or 5 minutes, exactly. Fantastic. So, throwing the floor open. Does anybody have anything to say about anything that anybody else has said?
So could I make a comment about the last question? This is certainly not at the scale in which we're talking about now, but I did want to put on everyone's radar. There's an initiative in the United States around research repositories. So it's called the Generalist Repository Ecosystem Initiative. And this is a collaboration that we have with the Zenodo team. We're one of the partners on it together. And then there are a number of other repository platforms that are well known, I'm sure, to everyone in the room. But the entire premise is that you're bringing together commercial and open source partners in what they're calling a model of co-opetition. And so there are funds to basically support everyone coming to the table, establishing some clear guidelines around best practices to support interoperability while still allowing each of the repository platforms to be able to advance their own goals. So, I mean, this kind of goes toward what we've been talking about throughout our time together, but, how do you bring people together? And it's not a lot of money, but it is enough so that we are invested and we're paying attention and participating and helping to drive best practices forward. And so this is through the National Institutes of Health.
Wonderful, thank you. It's just the fact that you've been able to get funding for that sort of stuff. And often what it takes is just to roll over 1 or 3 funding cycles before you can actually start building a proper community. That's how Gravitas works. A lot of stuff, unfortunately, just withers and dies within the funding cycles. Not good initiatives, but they bloom and they wither. At the same time, David, I know that you managed to get something similar funded in the Czech Republic. And you're a modest person, so you're going to deny this?
Not yet, but it's in progress. We are just building an infrastructure of, or basically a platform that allows user communities to build their own data repositories, and they don't have to take care of the low-level technical infrastructure stuff by themselves.
How did you argue to get that funded? Not so much the tech. I know in your hands the tech is going to be solid. How did you manage to get that funded?
It's not a question for me. It's about my pay grade, definitely.
All right. All right. Any further questions? Questions from the floor? Anybody wants to bag Kuba because he's had too much time? No? All right, then can I incentivize you to give these people another good round of applause? Thank you for joining, and I'll give the rest of your day back to you, Christy.
Very good. Thank you, everyone.
Thanks for having us. Bye-bye.
Up to you. Oh, I expect you to be chased off the podium. Sorry? I expect you to be chased off the stage, but I'm not. Oh, I am. Wonderful. Thank you.
Okay. Thank you, Guido. Thank you, everyone. And the panel 2 is over. Thanks a lot. I think Gideon can stay. Because we still need you for the next one. So don't leave the stage. We still want you there, if that's okay. I think now is time we are almost done for the event. Only 2 presentations missing, and they are short compared to the 45 minutes panel. Guido, thank you for leading the panel and making some popular and difficult questions, which require technical and expert answers. So I think now, moving swiftly on to the next session, we will have 2 speakers. One, you already know him. He's Gideon from ESADE. He's there. And we would like to call once again on stage Pedro Ferreira, our technical coordinator. So we will start with Pedro, who will talk about the future of the Science Mesh. He'll talk about the technical development and the user onboarding, while Gideon from ESADE, he will talk about the business impact of the Science Mesh. So as you have been seeing till now, we've been talking about the motivation behind the Science Mesh, how it has been helpful for different researchers, what was the technical novelty behind the Science Mesh, and also what will be the contribution of the Science Mesh towards the EOSC and open science landscape. Now it's a moment to talk about the future. And with this, I'll pass the floor to Pedro. Are you ready? Okay, go ahead.
Hello. Oh, no, okay, that sounds much better. Thank you very much. So, and thank you for the kind introduction, Rita. So, indeed, I will be, this presentation will be shared by myself and Gideon. And so I've been tasked with doing the first part, so talking a little bit on what are our plans for the future. So I will start by, first of all, making a bit of a summary of where we are at the moment, what have been the latest developments within the Science Mesh, and then finally I'll switch over to talking about the future, and in particular what are the plans for the continuation of the project, both from the technical but also from the, let's say, federation point of view and the community building point of view. So where are we right now? The mesh right now consists of 5 interconnected pre-production sites. So it might look like 5 is a very modest number, but actually, the amount of work that has been invested into this will contradict that. It's actually this pre-production mesh at the moment is actually an interconnected set of nodes which are able to share, let's say, to share files and to use the invitation workflow, which has been demonstrated already before, between them, and is irrespective of their vendor. So we have sites which are using OnCloud, sites which are using Nextcloud, and even different versions of the same software. And you've noticed I've added an asterisk next to CERN. That's because we are already on OnCloud infinite scale at CERN. And right now we are still having some issues, actually, which is one of the things that are currently being worked on, which Giuseppe, Gianmaria, and others are working on, sorting out the connection between OSIs and Nextcloud, because there are still some bugs, let's say, there, which are now being sorted out. So this is the current state. So these sites are in pre-production. This means that we have we are using basically the software which would be otherwise in production, or which will be soon in production, and using an infrastructure which corresponds to the production infrastructure, user database that corresponds to the production user database. Of course, then the data which is available to users on these pre-production sites is not the same that is available in production, but this already gives us, quite high certainty that it will work out in production. So one of the things that is currently being worked on is, of course, the stabilization of Riva intermediated transfer. So this is what I meant before by the work which is currently being done at CERN and also by PonderSource, which is making sure that the compatibility between all different versions of vendor software is achieved fully. And we are already pretty far into this process. At the previous presentation we've done at the CS3 conference in Barcelona, I actually mentioned that we managed to get the major vendors, OnCloud and Nextcloud, to include some patches which we have produced into their own stable branches, which means that this made basically integration fully possible on our side, and now, of course, we are going to we are again in a dialogue with them to ensure that these bug fixes that we found along the way are included in stable versions. And this is, of course, one of the reasons why we are not in production yet, because that has to be done, and then we will be moving to production. So in terms of deployment, we have a regular federated deployment task force, a weekly task force which meets weekly, which has been doing a lot of coordination of the deployment of the effort, of the deployment effort throughout the road to production. And big thanks to David Antos, who was here just before on Zoom, and who's been leading this task force for the last few months. And through this FDTF, we are working to move the remaining nodes to pre-production, because the remaining nodes in the consortium are still in, let's say, proof of concept state, and consequently to production. At the same time, we are also working on continuous improvements in the documentation of our processes, our onboarding processes, our configuration processes. It's of course very important that it's as easy as possible for people to install the software, to set it up, and to get it running. And at the bottom of the slide, you actually see the really nice table that David and the guys put together, and which shows the tests that have been done in the pre-production environment, and show, all these green boxes are basically successful tests which have, proven beyond any doubt that the transfers can be done between these systems. So let's then go from where are we to where are we going? And this, of course, is a discussion which is much more open-ended. There's still a few things that that we are, of course, uncertain about. And tomorrow we have our last all-hands meeting, and we will also probably take some decisions which will influence some of the things that I'm now saying. But nonetheless, we have an idea of where we're going in all of these matters. So with regards to technical development, we will of course be advancing the OCM standard, and I believe that someone, maybe even Guido, mentioned before that one of the companies which is participating to whom we're outsourcing some of the effort is even trying to get funding to work on OCM and to improve OCM. So I think there is enough interest in the community, also from the vendors, in advancing this standard and fixing maybe some of the kinks that still, exist here and there. Of course, then, if we want to keep the Science Mesh alive, we want to also provide continuous updates on Science Mesh, on the Science Mesh app, and on Riva. Riva, of course, there's something that, for instance, we use at CERN, and it's something that's actively used, so there is a very little risk that in the future that won't be done. The Science Mesh applications, of course, that involves already additional investment, but I'm sure that within the consortium we will find enough, willpower to work on this in the future. Then, with regards to the onboarding, the focus is now to move the current nodes to production as soon as possible. There is some technical work, which I've mentioned previously, which has to be done, but it is advancing steadily, and we're nearly there. So it won't take long until we will be able to do that. At the same time, we are trying to start onboarding also some new partners. There are a few interested organizations would like to start working on joining the mesh. So, and this is also acts as a reminder of maybe some of you in the room or online who may be interested in joining this effort. Just let us know, because this is the right moment to start working on that. Of course, there will also be some continuation work, which was also already mentioned here. Well, that was the second item. There is a subset of the consortium, of the current project consortium, plus other friends who are working on a proposal for EOSC, for an EOSC service based on which integrates with the Science Mesh and based on the technology that we have developed. So this would, of course, be great for the continuation of this project if they succeed in that. And there's also a growing list of interested parties in a follow-up project. So once again, if you are interested, if you have interest in joining this effort in helping us continue this project and making the Science Mesh, a reality, a production service and start growing it from there, let us know and let's talk about it. So just some conclusions. I think we managed to prototype and bring to pre-production state the base technologies of the mesh. You've seen the demos before. I think they're quite clear on what is possible and what this technology can deliver. And the consortium remains committed to a move to production, despite the formal end of the project. And we know that officially we are just weeks away from finishing everything. But we have plans, we have constitution, we have a series of bodies that we are going to establish, and tomorrow, of course, some of these questions will be clarified. And we are certain that the Science Mesh will remain alive through the administrative bodies that we will set up. So yeah, more on that tomorrow. So I will just finish by reminding you that our site, sciencemesh.io, contains all general information about the platform, the application catalog, and also documentation resources. So feel free to go there if you need any information. And I believe that's it. So I think I will.
Thanks, Pedro. Yeah, pass the floor to Gideon.
Okay, so by now you guys know our role was really thinking a little bit more about the longer term sustainability of the mesh, what happens when the project funding ends, funding models, all these things that get us very excited. Because of time, I think I have negative time, Rita, if I'm right. So I'm going to give a very brief, very surface level overview of these three topics. But if you want to know more, I really encourage you to read this document that should be publicly available quite soon. Before I get into it, there's just one thing to remember, I think. From a purely technical point of view, sustainability was a core component of the Science Mesh from its inception. And I say that because it's built on a mesh of sites that themselves are sustainable and funded, like Ron said, typically through national means. And the actual meshing of sites is completely end-to-end, which means that there aren't really that many components to the direct Science Mesh cost structure. With that in mind, though, there are some essential operations that need to remain in place. Bear in mind, this is a moving target, like Pedro said, but what I can say is that this will likely be as lean and lightweight as possible. So there'll be an executive board, for example, ratifying governance documents that are binding for all the mesh members, a steering group where you can have, all members can have voluntary representation, an operations team, a help desk that's been set up and needs to remain in place to deal with the various onboarding issues that might arise. And of course, we need some dedication to software maintenance. A large part of our work was thinking a little bit about funding models, financial sustainability, and these sorts of things. This is also still a work in progress, so consider this simply an ideas bank for future iterations, like the possible follow-up project that Pedro mentioned. I'm sure we'll work on this a lot more then as well. So firstly, as a public service aiming to serve the wider research community, grant funding remains the most natural choice to fund an initiative as ambitious as the Science Mesh, especially in its early years as it adopts its first users. And the CS3MESH4EOSC funds have been instrumental in securing the future of the platform. And with it, we believe to have created the conditions for the mesh to demonstrate real benefits to its early users. The second, call it idea, is this, some sort of membership fee structure, whether that be at the point of, let's call it research institutions, or further upstream at the sync and share services and sites themselves. The big challenge here is, convincing everybody that the Science Mesh generates enough value to justify any kind of fee. For both of these sort of sub-models, it's important to note in that picture, free at the point of use for the individual researcher. That's something we obviously value quite highly. So now, completely opposite to what I just said is service fees for researchers themselves. We've included this idea just to be thorough, but for a lot of reasons, most of them quite obvious. This is something we want to avoid as far as possible. Hence the thumb down. Third-party vendors could also offer products or services that might integrate within the Science Mesh architecture. The two things here being convincing vendors that the platform is viable and having them produce content that end users value. And then finally, some sort of subsidization from commercial activities. The exact pathways to make this work haven't been defined, but the idea is simply to leverage the financial capacity of industry users. So where to from here? So we've identified a few sort of areas for priority investment moving forward, all of this being underpinned by the essential operations that need to remain in place. So for example, enrollment of new nodes, making sure the Science Mesh is always expanding, developing admin capabilities, so making sure that Science Mesh members are empowered to manage their respective nodes. New user communities, this might seem like an obvious one, but crucial to think about. We could have, in my opinion, all the connected nodes in the world, but without a strong user base, without researchers that know about the mesh and that use the mesh, our efforts might be futile. And then, of course, keeping a constant eye on the ever developing advances in data science and machine learning might present some opportunities for new applications. To put this in some sort of broad timeline, the immediate needs is obviously to bridge the Science Mesh into that early adopter community and further explore funding and sustainability pathways. But like what's been mentioned a couple times before, I think achieving that critical mass for the Science Mesh is really important before we can have real grown-up conversations about some sort of membership fee structure, right? Over the medium term, Science Mesh can grow by expanding the network of nodes, engaging with more scientific communities. And, in the long term, we might find ourselves in the position of sustaining the Science Mesh where we've become one of the main platforms enabling fair data and open science for researchers Europe-wide. I think I'll end it there. Thank you.
Thanks, Gideon. Okay, last questions for Gideon and Pedro. From online audience, do we have questions from the online audience? No? Just checking quickly. There is something there. Okay, no. Pedro and Gideon, thank you very much for your presentations. And now it's almost over. So we are going to close this event how we started, listening to our dear Kuba, who was the coordinator behind the overall CS3MESH4EOSC, who will say a couple of words before we can call it a day. Kuba, thank you very much.
Okay, so, well, I think everybody just wants to go home, so let me be brief. Thank you very much. Thanks a lot for staying the whole day. So, as it was, I think, highlighted, it's not the end, but there will be a continuation of different activities that have been initiated by the project. So definitely watch this space if you're interested in knowing what's coming up next. And yeah, and that's essentially it, I think. I just wanted to again express my big thanks to Rita and the team that prepared the event. It was very nice. And thank you very much for your participation, and that's it.
I'd like to add a couple of words to what Kuba just said. I would like to thank, first of all, for the invitation from AGI for us to organize our event during your annual conference. We really appreciate that. Also to thank your presence for those who are here in Poznan, but also of the online audience who followed us online. And also would like to thank the technical team, which is also Jakub. I would like to thank you for his support. And also to my more personal note, to my colleague Ruben, my colleague Letizia, and also another colleague who is supporting us from the office, Luigi, who also worked well together, worked hard to deliver this event. As Kuba said, this is not the end, so if you want to be in touch, keep in touch. We want to keep in touch with you and touch base in the next days in the near future. Thank you very much, everyone.